JavaScript was created to bring data processing and dynamic behavior to web pages. At the time, JavaScript was essentially shoehorned into browsers, and as time progressed, so did JavaScript. But the JavaScript engines that popular browsers of the day used were extremely slow when compared to other interpreted, much less compiled languages and environments. But then Google created the Chrome browser and the V8 JavaScript engine, and it all changed. Hi, I am Jeremy McPeak with Envato Tuts Plus, and I invite you to spend a few hours with me as I teach you the fundamentals of writing Node.js applications. We'll start by looking at how to write command line applications for Node.js. You will learn how to read and write data to input and output streams, use CommonJS and ECMAScript modules, as well as make HTTP requests and create and trigger custom events. You'll then learn how to create and run an HTTP server. I'll show you how to generate content and respond to requests, how to extract data from the query string, handle and process form data, and serve static files. Now, admittedly, no one creates an HTTP server these days. Instead, they use a web framework like Express. So I will teach you everything that you need to build web applications with Express. You'll learn about request routing, the model view controller pattern, handling and processing form data, and how to write and use middleware. You'll learn how to use the Handlebars view engine to generate HTML responses, and then finally, we will connect to a MongoDB database to store, update, and delete data. We have a lot of ground to cover. Now, let's get started. Of course, before we get started, we need to go over what you need, not just for this course, but to develop Node-based applications. And the first is you need Node. Now, if you already have Node installed, just be sure that you have the latest version. But if you have never installed Node, this is a perfect time. Not only will you need Node to, of course, build Node applications, but if you build any web-oriented application for any other platform, then you will need Node Package Manager, because that is how we manage all of our dependencies. Now, if you go to nodejs.org, you're going to be greeted with two options. Let's ignore the version numbers for now. Let's focus on the LTS, which stands for long-term support, and then the current version. Now, LTS is, well, as its name implies, it is long-term support. This is typically what we would use in a production environment because it is more stable. It is also going to be supported for several years. And as a platform that is going to be running our applications, that is essentially what we want. However, there are some times when we might need some of the newest features, and that is where the current version comes in. But as I am developing applications, I typically reach for the LTS just because it is more stable, it is supported for a longer period of time, and it mirrors what I would have in production. So then we can focus on the version numbers. As you can see, LTS here is version 16.17.1. The current version is 18.10.0. Now, in this course, there really isn't anything specific that we need version 16 for. But however, as you are developing applications, you might need to pay attention to the version number because you might need to use certain features that are only available after a certain version. But for our purposes, 16 is going to be fine. Now, the installation is very straightforward. In fact, all you really need to do is just take the defaults and you will be good to go. Now, for Windows users, there is a screen in the installer that you might have a question about. Basically, it says that there are some modules that need to be compiled from C or C++. And do you want to automatically install the necessary tools? One of those is Chocolatey. Now, that is completely and totally up to you. But for most of your projects, you can get away without checking that box. As I said, take the defaults and you're going to be good to go. But if you want to include that option, then feel free to do so. Now, the next thing you need is a code editor. And there are many code editors. Some are free and some are not free. And even if you have to pay for a code editor, that doesn't necessarily mean that it is better than the free versions. In fact, the best code editor for JavaScript is free. It is Visual Studio Code. It is what I use really for all of my web development, especially anything related to JavaScript. And the great thing is that it is cross-platform. So feel free to download that and install it. But of course, you can use any code editor that you want. One that is popular is Sublime Text, which is not free, but it is a good code editor. And if you like Sublime Text, then feel free to use that. Another option is Atom, which is at atom.io. Now, Visual Studio Code is actually built upon Atom. So there are a lot of similarities, but still, when it comes to working with JavaScript, nothing can really touch Visual Studio Code. Now, before we move on, let's be sure that everything is working as it should. Node is a command line platform. However, you can build applications that have a graphical interface. In fact, Visual Studio Code is one such of those applications. But every Node application boils down to the command line. So after installing Node.js, you are going to have a command called node, and you can say -- version after calling the node command, and it will tell us what version is installed. We see that the version is 16.17.1, which is perfect. So in the next lesson, we will take a look at using the read, eval, print, and loop feature, or REPL. There are two different ways that we can use Node.js. The first is to use an interactive environment that we can use for experimentation. We access this interactive environment by just running the node command. And then from there, we can type any JavaScript expression and we can actually see the results of that code. Now, the second way that we can use Node.js is to execute a JavaScript file. That JavaScript file would essentially be our application. And we would do so by using the node command once again. But then we would follow that up with whatever file name that we wanted to run. And of course, the file name itself is arbitrary. We can name a file whatever we want, fill it with our JavaScript code, and execute it. And we would be good to go there. But for right now, I want to talk about this interactive environment because it is helpful. This gives us the ability to test out code without having to create a whole new application and running that application. Now, this is typically what's referred to as read, eval, print loop, or REPL. I don't really know how that is pronounced because there is no official way to pronounce it. I pronounce it as REPL. So that could be wrong. I am perfectly fine with being wrong. So the way this works is we type some JavaScript code. I'm going to write the code of console log. We're going to write out hello world to the console. We're going to follow that up with a semicolon. So whenever we press enter, the REPL environment is going to read that input. Our input is this JavaScript code. It's going to evaluate that code, and it's going to print it out here on the screen. And then it's going to loop back to reading, or at least waiting for us to type something so that it can read it. So we typed console log, passing in the string of hello world. It evaluated that code to output hello world. But then we see undefined here. Now, this really isn't unexpected because if you've done anything inside of the console in a browser, you would see the same behavior. And the reason why we see undefined is because the code of console.log returns undefined. There is no value that is returned from that statement. So therefore, even though there is some side effects to calling console.log, there is no return value. So thus, what is displayed on the screen is undefined. But let's do this. Let's create a variable called message. We will assign it a string value of hello world. And whenever we execute this, we see undefined as well. But it's the same thing. Yes, we created a variable, but the statement itself returns undefined. It doesn't return a value. However, if we simply type message, message itself returns a value because we assigned a value to it. So therefore, we see the value output. Now, as you may have noticed, as I typed the message variable, I have not executed this code by pressing enter, but yet the environment is outputting the value of that variable. So it is still reading what I type and it is evaluating that. So if I take the message variable and I concatenate another string, this is another string, we can see that it is being evaluated and it is outputting that, giving us a preview as to what that code is going to result. So as you can start to see, this gives us a very powerful environment so that if we ever need to do any kind of testing, any time of experiments, this is a perfect way that we can do that. But how can we write a function? Well, we can just start by defining a function. Let's call this sum, to where we accept an A and a B. And of course, we want to take those values, add them together, and return the result. And so I pressed enter after the opening curly brace. And you can see that now there's this ... This is just a continuation of the statement that I started on the previous line. So we can go ahead and we can define the body of this function, return A and B. We will close that function, press enter, and now we have our sum function. So we can pass in two values and we can see those results. So once again, let's take our message, let's concatenate a string, and then let's call our sum function. Passing in two values, press enter, and we see the results. Now, there are a few commands that you need to know as you are using the REPL environment, and we will talk about those in the next lesson. As you are as you are playing in the REPL environment, there are some commands that you want to be aware of. The first is probably the most important, how to get out. Now, all of the REPL commands begin with a dot. As you can see here, it says type .help for more information, which we can go ahead and do. The command list is very short, but what I want to start with is exit. How do we get out? So simply type .exit, and you are out of that environment. Now you can also see that it prompts us with, you can press Control-C to abort the current expression. So if we are typing a statement, we can press Control-C to get out of that expression, or to exit completely, we can use Control-D as well. But let's get back in. And let's create the message variable from the previous lesson, because whenever you exit a REPL session, everything that you have done is no longer there. It is out of memory. So if you want to restore anything from that session, what you have to do is save that session. So let's create our message variable once again. And let's also recreate the sum function. So we accepted A and B. We simply returned A plus B, and there we have that function. So these are two things that we might want to use in other sessions. So what we could do then is essentially save this session into a file. So we would use the .save command. We would follow that up with whatever name that we wanted for the file name. I'm going to call it mysession.js. And our session is saved. So now we can exit. Let's start a new session. And now we want to load that saved session. We do so with the .load command, and then we specify the file name, mysession.js. We can see the code from that session. There is our message variable. There is our sum function. So now these things are available to us. So we have the message variable. We can see the result there. If we wanted to execute the sum function, we can do so because that has been loaded into this session. Well, let's say that, okay, we want to define a function called diff so that we can subtract one number from another. And then as we are into the body of this function, we decide, well, no, we don't necessarily need this function. What can we do? Well, we can use one of two commands. The first is .break. The second is .clear. They do the exact same thing because .clear is just an alias for .break. So as you are in the midst of a statement, you can use .break or .clear, and it breaks out or it clears that statement. Now, as with pretty much all JavaScript environments, there is a global context within a REPL environment, and it is slightly different than what you would find within a typical Node application. So within a Node application, you would import different modules in order to provide different functionality. Like if you wanted to create an HTTP server, you would import the HTTP module. It's not imported automatically. However, in the REPL environment, it is. So if you wanted to look at the status codes that are provided from the HTTP module, you can do that. You don't have to import HTTP because it's automatically done for you. And so every module that is built into the Node platform is loaded by default. And as with most command line tools, you can use the up and down arrow keys in order to search through the commands that you have run. And if you wanted to run that command again, all you have to do is press enter. And there you go. And those are just a few tips and tricks for working with the REPL environment. In the next lesson, we will create our first Node application. In this lesson, we are going to create our first application. It's going to be just a simple calculator, and it will be command line based. Now, that might sound a little weird because when we think of a calculator, we think of something that's visual. But most Node applications are command line applications. And it makes perfect sense when you think about it because most Node applications are web applications. And of course, yes, the user opens up their browser, they navigate to the web app, and they interact using what they see in the browser. But that's not really the application. The application is running on the server, and it is handling all the requests that are coming in from the browser. And the web server doesn't need a UI, so instead it's just a command line application. Now, you can build applications with a graphical interface. For example, Visual Studio Code is one such application. This is built using what's called Electron, which is really nothing more than a UI framework for Node applications. Now, that is an oversimplification, but essentially, that's what it is. So let's create a new file. I've created a directory called just Node apps. The idea being that all these first applications that we create, we can just throw into this folder and we'll be good to go. And I'm going to call this calc.js. Now, we can approach writing applications in various different ways, especially when it comes to our calculator application, because we are going to rely upon an object called process. Now, the process object represents the process. This is our application's process. And so this process object gives us a lot of what we need in order to interact with the user. Like, for example, we need to be able to output information. We also need to be able to receive input from the user. And to do that, we have two different properties. The first is called standard out, or std out. That is the standard output. There is the standard input, which is std in. Now, if you've done any work with C or C++, then that's going to sound somewhat familiar to you. And it's the same basic principle in that we use the standard input and the standard output to work with, well, input and output. So let's start with standard out, because that's the easiest thing to do, because that is writing something out to the command line. And so we have a method called write. We can pass in a string. So this is a calculator. We are going to have essentially a prompt for the user to provide a simple equation. We don't want anything complicated, because essentially what we are going to do is take the user input and evaluate it. It's not going to be very safe, but for the sake of getting familiar with this, it's going to be fine. So our application right now just has a single statement. We are writing something out to the standard output. It simply says enter your simple equation. And so whenever we run this application in the command line, we will say node space and then the name of our file, which is calc.js. And voila, we see the output, enter your simple equation. So that's great. But you might be thinking, well, what's the difference between that and console.log? So let's take a look at that. Let's add a call to console.log. Let's have the same text. So let's just copy and paste, and then let's run that in the command line. Now notice we see the result of two strings. We have enter your simple equation, and then on the same line, we have enter your simple equation. Okay, so let's call console.log again with the same text, doesn't matter. Let's run this again, and we're going to see something a little different. So now we see that same line to where we have the repeated enter your simple equation, but then we have a new line that has enter your simple equation once again. So here's the difference. Console.log adds a carriage return or a new line to whatever message you pass to it, which is perfectly fine if that's what you need. But for our application, I don't want to do that. I want to output the message, enter a simple equation, and then the user will type their equation and it will appear on the same line as our prompt. So that is why I am using process standardout.write. So that's great. We have our output, or at least we have our prompt. Now we just need to be able to retrieve the user input. So for that, we will use standard input, stdin. Now, here's the thing about standard input, standard output, and just about anything that involves data. These are streams. And if you're like me and you hear the term stream and you think of streaming video over the internet, well, that is exactly what this is, at least as far as the concept is concerned. So instead of Node just reading all of the input or all of the output and storing that in memory, it reads chunks at a time. It streams that data, essentially. And one of the cool things about this is that it is all event-driven. So for the input stream, which is the standard input, we can listen for an event called data. We do that by using the on method on the standard input object. And then we just need to supply our callback function. This is going to retrieve the chunk of data that was currently read from the stream, which in our case is going to be the user input. So right off the bat, we can just write out that chunk to the console. However, the chunk by itself really isn't going to be enough, but let's run this and let's see what it looks like. So let's type just a simple equation, 1 + 1. Now we see buffer 31 to be 31, blah, blah, blah. That's not very useful for us. So essentially what we need to do is transform this chunk into a string. Now, if you think in terms of a stream, then it makes sense that this is a chunk, because remember that this data is being read as a stream. So we need to convert this chunk of data into a string. And those two words sound too similar. So I'm trying to be very clear as to what word I am using. So we are going to take this chunk of data from the input stream. We're going to convert it into a string. And it wouldn't hurt to go ahead and trim it just so that we can normalize it. Let's go back to the command line. And I want you to notice that, yes, of course, we have the buffer here, but notice that the application did not exit. And we know that it didn't exit because we are not sitting at the command prompt. And the reason for that is very simple. Now that we are listening for the data event on the standard input stream, the application is sitting there waiting for user input, and it will continue to wait until we exit the process. So let's save this. Let's exit the process by hitting Control-C, and let's run the application again. We see our prompt, enter your simple equation, so we will do 1 + 1 once again. And now we see 1 + 1 output into the console. That's what we would expect because that's the code that we wrote. So if we type something else and press enter, we can see that once again, it is writing that out. So it is taking our input and then it is simply writing that back out to the console because that is exactly what our code is. So let's exit the process. And let's modify our code here. So now that we know how to read the data from the input stream, we can store this in a variable. We'll just call that simply str. Or no, let's do this. Let's call it input. And let's give ourselves an escape hatch. Because as you'll remember, the application is going to continue to run because it is listening for any user input. So let's say that if the user types exit or quit or something along those lines, then it's going to exit the application. So if the input is equal to, let's just use quit, then we want to exit the process. We do that using our process object. It has a method called exit, and then we pass in 0. Now, we don't have to actually pass 0 here. We can pass nothing, but I tend to pass in the numeric value of 0. Now, This is the exit code. 0 basically means that the process ran without any issues. And it's just my preference to be explicit in that exit code. However, you cannot pass 0 if that's what you would prefer. But of course, if there is an error, then you want to pass the appropriate exit code there. And so now that we have our escape hatch, we need to actually perform our arithmetic operation. However, since this is accepting user input, it is possible that the user would provide something that we don't know what to do. So it is useful to wrap all of this within a try-catch. So the first thing we are going to do is try to eval whatever it is that the user input. So if it is a valid JavaScript arithmetic operation, then that's going to be fine. If it's not, then it's going to throw an error. And so we need to handle that error. And we can just write out a message to the console that says, I don't know how to do that. But if the evaluation is successful, then we want to display the result of that. So we can just write that out to the console using console log. We will provide the value, and then we can prompt the user to, once again, enter a simple equation. So we can essentially put ourselves into a loop so that the user can provide an equation, we evaluate that equation, we output the results, and then we prompt the user. And we keep doing that until the user types quit. So let's give this a whirl. Let's run our application. Enter your simple equation. 1 + 1, well, that's 2. Enter your simple equation. 5 times 10, that's 50. 5 divided by 2, well, that's 2.5. So everything is working fine, but now let's be sure that we can quit. Although before we quit, let's do something that is not an arithmetic operation. Well, I don't know how to do that. Perfect. And then it prompts the user to enter a simple equation again. So now let's quit. The application exits, and there we go. So now we have a very simple equation, but this is just one of the ways that we could write this. And it is a little verbose. There are modules that we can use to make this much easier to write and much easier to read. And we will look at that in the next lesson. In the previous lesson, we created a very simple calculator. We did so by using the standard input and output. We listened for the data event for the standard input so that we could retrieve that information. We converted that chunk of data into a string so that we can then work with it. We provided an escape hatch by being able to type quit. And then, of course, we performed the arithmetic operation if it was valid. And then we prompted the user to provide the equation again so that we got into that loop. Now, that's all well and good. This code works, and there's nothing wrong that you can say about code that works. However, we can make this better, at least as far as readability and writability is concerned, by using modules. Now, there are 2 different types of modules that are supported in Node. There is the CommonJS module. That has been supported since the very beginning. And then we have the built-in ECMAScript modules. And the whole reason why we have the ECMAScript modules is because of the CommonJS modules that were made popular with Node. Now, Node is transitioning away from CommonJS modules, so we can use CommonJS modules or ECMAScript modules within our application. In this lesson, we are going to use CommonJS modules so that in the next lesson, we can look at ECMAScript modules. You can use whatever you want, but do know that the ECMAScript modules are now part of the standard, and Node is transitioning away from CommonJS to using ECMAScript modules. All right, so I created a new file for this calculator application because we are going to be using CommonJS modules here. And the one that we are going to use is called ReadLine. Now, if you're not familiar with CommonJS modules, we have a require function that we call. We pass in the name of the module that we want to require within this file, and then we are given that object that is exported from that module. In this case, it's called ReadLine. And we want to create an interface that works with input and output. It doesn't have to be standard input or standard output, but for our application it does because we are working with standard input and output. So the first thing that we are going to do after we require ReadLine is create an interface. I'm just going to call it RL. And we will use our ReadLine object to access a method called createInterface. And we will pass in an object that has two properties. The first is input, which is our input for our application. That is the standard input. And then there's an output property, which is the standard output. And then from there, instead of using like the write method to output something or listening for the data event on the standard input, this ReadLine interface gives us methods that we can use to write out to the output or read from the input. So if we wanted to prompt the user with something, we could use a method called prompt. Then we could pass in whatever message that we wanted, and then we could read the user's response with another method. But I like to do this because that is a very common pattern to request something from the user, which you can call a question, and then get an answer back. So the ReadLine interface has a method called question, and we can provide the question that we want to write to the output, which in our case really isn't a question, but who cares? The idea is that we request something and we get a response back from the user. So we are going to tell the user to enter your simple equation, and then we pass a second argument that is a callback function for when the user provides their input. We can call this answer, but let's have some parity between this implementation and the previous implementation because we used this input variable name. So we will call this parameter for the callback function simply input. And for the most part, we can take the majority of this code and just lift it out and paste it into our new implementation. We, of course, need to make a few changes. Like, for example, we can still exit the process using process exit. However, in our case, we don't want to do that because this ReadLine interface is now holding on to the resources of standard input and standard output. So we essentially want to release those resources. If we don't, then it could cause some issues. So we can use a method called close. And that does several things. For one, it releases the resources that it is currently using. So that is the input and output. But it also returns the execution context back to the application. So it essentially tells the application, okay, I'm done with this. And so then the application can close. Because if we don't close our ReadLine interface, we'll just get an application that is kind of stuck. It looks like it's waiting for user input, but it's not really going to do anything because, well, it's stuck. We haven't released those resources. So we're going to call the close method on this ReadLine interface. But if the input is not quit, then of course we want to try to perform our calculation. So let's move that into an else block. And at least for right now, we aren't going to prompt the user to provide another equation because we have to find some way to essentially call question again so that we can prompt the user, we can get the input, we can do whatever we need to do, and then call question again, prompt the user, get the, you get the idea. Since we are using a callback function, it makes it a little more difficult to do that. But for right now, we have an application that will work. There's still an issue here, but that's okay. Let's run it, and then we will see what happens. So we are going to run calc_common.js, and we are prompted to enter our simple equation. 1.1, we see the return value of 2. That's great, but notice nothing is happening. So what happens if we type 2 plus 2? Nothing. So we've gotten into the state of where the application is just kind of hanging there because, well, it's not doing anything. So we need to call close after we are done. So regardless of if the user provides quit or not, we need to close this. So let's stop the application. Let's run it once again. Let's do 4 plus 4. We see the result of 8, and then our application exits. But I want that loop. I want to be able to prompt the user repeatedly every time that they get a result from our calculation. And one of the easiest ways that we could do this is just by writing a function, because this is JavaScript. Yes, it is object-oriented, but we can also use functional programming. And with recursion, we can call the same function over and over again. So I'm going to create a function called question. And this question function is going to call the question method. It will prompt the user. It will get the response. We'll go through the whole process of checking for quit and then performing the arithmetic. But then right here, instead of closing, we'll just simply call question once again. So we get into this loop, but we have to essentially prime the loop by calling question to begin with. So with that in place, we can execute this application. Let's enter our simple equation. 2 + 2 is 4. Great. We are prompted again. Let's do 5 divided by 2. We get 2.5. So it looks like everything is working. Okay, I'm done. Let's quit. And there we go. We are out of the application. Now, if we compare this with what we wrote in the previous lesson, this is more concise. Absolutely. A lot of times, the best approach is with a lower level API. However, there is something to say about this approach that uses the ReadLine module. And we would definitely start to see an improvement of using the ReadLine module if we started to add more features and make this calculator more complex. Well, in the next lesson, we are going to, once again, rewrite our calculator application, but we are going to do so using ECMAScript modules. In the previous lesson, we rewrote our very simple calculator by using the ReadLine module. This gave us a higher level API, which made it a little bit easier to work with input and output. And in this lesson, we are going to rewrite this once again, except that we will use ECMAScript modules instead of CommonJS. And really, we can get started by just copying this common file. Let's paste it in. We, of course, need to rename this. I'm going to use the name of calc_es, but the extension needs to be different. Node thinks that a JS file is a CommonJS module file, or at least it's using CommonJS modules. If you want to use ECMAScript modules, the file name has to use the MJS extension. So if you write and use ECMAScript modules, which I encourage you to do, because that is the way that everything is going, then you will need to use MJS extensions for your files. Okay, so for the most part, the code is going to remain the same, at least initially. We are going to almost completely rewrite this so that it is very clear as to what's going on, and it will be much more concise. But for right now, I want to focus on importing our modules using ECMAScript syntax. So of course, we do that using the import keyword, and then we specify what we want to import. For the ReadLine module, we want to import all as ReadLine, and then the module is simply ReadLine. So there we go. That's very simple. But we also want to import the standard input and output. So we will do that there so that we import standard in and standard out. And that comes from the process module. So that is going to simplify when we create our interface so that we can get rid of process dot, and then we can just use standard in and standard out. And we could simplify this even more so that we import standard in as input and then standard out as output. Then we can simplify this altogether so that all that we specify in this object literal is simply input and output. That really simplifies it, at least in my opinion. So let's do that. And we can get rid of this call to require because we don't need that. And there we go. That should work. So let's test it just to make sure we didn't break anything. Let's run calc_es.mjs. And we are prompted. So let's provide some equations. Everything looks like it's working okay. Let's see if we can quit. It quits. So there we go. We have ECMAScript module syntax here. But I want to make this much easier to read. Because really, when you start getting into the nitty-gritty of this with the question function and then the recursion and all of that, things just get, well, it muddies things up. So this is what I want to be able to do. Let's say that we get our inputs, although we can't really call it input now, can we? Since we are importing std_in as input. Let's just call this answer. And I want to await what is essentially going to be calling the question method to where we would enter our simple equation. And then we could use a while loop. So if answer is not equal to quit, well, then we will try to evaluate that equation and all of that stuff. But then we need to get a new value for answer. So we prime our loop on line 7, we prime it, we check the value of answer, we do something with answer, although we do need to change the variable name here from input to answer. Then we get a new value for answer, we go back through the loop and so on and so forth. So this is very clear now. We are in a loop. We're not within a recursive loop as we were with our question function. But then the last line, whenever we exit the loop, then we will close our ReadLine interface and we will release those resources and then the application will exit. So that's what I want to do. But we can't do it as it is currently written because the question method is not asynchronous. This does not return a promise, so we cannot use await. However, we can create a function called question that is going to have our query. And this will return a new promise that we will have our resolve function. And then here we will call the question method. We will pass in the query, which is our question. And then the callback function will be resolve. So that then, instead of awaiting the question method on our ReadLine interface, we just await the question function. That should work. That is much more clear as to what's going on, at least to my eyes. My brain can process this much easier. So let's give it a shot. Let's run our application. We will enter some equations and then we get into undefined. That was not good. And it looks like the problem was right here. We awaited our L question as opposed to just question. So that should fix that. However, Control C is not kicking us out of that loop. So that's one of the issues with using a loop, is getting into an infinite loop. But that's okay. Let's cd into Node apps, and then we will execute our application. We will be prompted to provide an equation. We submit that, we get the value. Great. So everything works as it should. Let's quit, and voila. So if you want to use ECMAScript modules within your Node applications, first of all, the extensions on the file names need to be m.js. And then inside of those files, you simply use ECMAScript module syntax to either import the things that you want to import and export the things that you want to export. In this lesson, we are going to start writing a command line feed reader. Yes, feeds, those RSS and Atom things that us old folks still use because they are useful. This application, however, is not going to be very useful because, I mean, hello, it's a command line feed reader. How useful can it be? But this is going to give us an opportunity to talk about several different concepts that you will use within your Node applications, as well as some of the common built-in modules that you will use in your applications. And we will also use some modules that are not built in. So it's a win-win, except for the end result is going to be very, very lackluster. So let's start by creating a new file. Let's just call it feedreader.mjs. Now I'm opting into using ECMAScript modules because that is how the Node platform is going. It is transitioning into using ECMAScript modules. So it just makes sense to opt into it. Now there are some very big differences between ECMAScript modules and CommonJS modules. Yes, syntax is a big difference, but there are also differences that we will talk about here in a few moments. Let's first of all talk about what I want to accomplish in this lesson. So I want to write a module that is going to allow us to manage a JSON file on the file system, because we need some way to store the URLs of the feeds that we want to read. So we are going to have a JSON file that will contain an array of the URLs. It would be nice to have some other information about those feeds, but the URLs are going to be sufficient. I mean, once again, this is a command line feed reader. How many features can we implement? So this feed manager, if you will, is going to have a couple of functions. One will get the links so that we can work with that information. One will be to save the links. Those, of course, are going to be reading the file and writing to the file. And this is going to be a separate module that we are going to start writing here in a moment. And we'll just call it feedmanager.mjs. And the idea is simply this. We will get our feeds. These functions will be asynchronous, so we can await them. We'll call get links. And then whenever we wanted to add a new feed, then all we would need to do is just push in the URL to that array. And then we, of course, would want to save that. So that is where the save links function comes into play. We would pass in the feeds array, and there we go. So that's what we want to accomplish, at least for right now. There is, of course, going to be much more code for the application itself. But for working with the feeds, this is a good start. So let's create a new file. We'll call it feed-manager.mjs. And let's take a few moments to talk about the differences between ECMAScript modules and CommonJS modules. So inside of this Node apps directory, where all of these other apps are, we're going to have our JSON file. So of course, in order to open up this file and read it and write to it, we need the path to that file. And one of the easiest ways to do that is to find the path of this Node apps, which is the directory that will contain that JSON file. Well, in a CommonJS module, that information was given to us for free. There are several global variables that every module has access to. One of those is __ file name. In a CommonJS module, this would give you the file name of that module. It would be the absolute path. So if this feed manager was a CommonJS module, file name would be c/users/jeremy.mcpeak/node-apps/feedmanager.js, the absolute path. Now there's another global variable available called __ dir name. I'm just going to call it directory name because that's what it stands for. And this returns the absolute path of the directory that contains this module. So once again, if this was a CommonJS module, then directory name would be c/users/jeremy.mcpeak/node-apps. And that is really what we would want, because then we could use that and then we could build another path for our JSON file. But in an ECMAScript module, everything has to be imported from a module. So this means that we have to do quite a bit of extra work in order to get the information that we would have gotten for free within a CommonJS module. So why not just use a CommonJS module? Well, because Node is transitioning into using ECMAScript modules. So the first thing that we need to import is a function called dir name. I'm going to call it directory name. And this is from the path module. Now, what this function does is return the absolute path to the directory of that path, which is great, except that you have to provide a path. It would be really wonderful if you could just call directory name, not pass anything, and it would give you the current directory of this module, but that's not what it does. And maybe in a future version it will, because that would be really helpful, but it doesn't. So we have to get around that. So that means we need an absolute path to a file within our current directory? Well, we don't really have one, but we have something that's close. We can use import meta. Now, this is not a Node thing. This is a JavaScript thing, and it gives us just meta information about the current module, which is this feed manager. So this meta object has a URL property, and that sounds pretty good until, you understand what its name is. This is a URL. So it's not necessarily a path. It's a URL that represents the path. It's a file URL. So let's run this and we will see the results here. So that was feedmanager.mjs, and there we go. It uses the file protocol because this is a file URL. But after that, we have essentially the path that we need to pass to the directory name function. But there's encoding and things like that. So really it would be nice to have a utility that would essentially convert this from a file URL into an actual file system path. And we have one. It's a function called file URL to path. And this is from the URL module. So we can essentially emulate that __ file name variable by using file URL to path and then passing in the URL of this particular module. So that's great. And with that, we can then emulate the __ directory name variable by calling the directory name function and then passing in the file name. So that is wonderful. So now let's go ahead and let's write out that directory name and let's see what we get. So let's go to the command line. We'll run the application, and there we go. We have the absolute path to our Node apps. That's perfect because that is where our JSON file is going to go. So we need a path to that file. Even though it doesn't exist, it would be nice to store that within a variable. So we could use string concatenation. We could use a template string so that we use directory name, and then a slash, and then our file name, which we could just call feeds.json. But no, I don't like building URLs that way. And thankfully, we don't have to, because the path module has another function called join. And we can use this function to essentially build a path, so that every argument that we pass is a segment in that path. So we can start the path with the directory name that we have. Then the next argument will be the next segment of this path. And thankfully, this is a very simple path to where we just need a file name. So we could call that simply feeds.json. And then that gives us the path to our file. So if we wanted to output this just to make sure it works, there we go. Now, of course, this file doesn't exist, but that's okay. You don't have to have a file in order to have a path to that file because the path is just a string. But one thing that we can do with a path is check to see if that file exists. And if it does, then great, we can read it. If not, then we of course need to create that file. And we will look at how to do that in the next lesson. In the previous lesson, we primarily talked about paths. We talked about how we can get the absolute path to the current module. We talked how we can get the absolute path to the directory that contains the current module. Then we also talked about how we can build a path. And now that we have a path to our JSON file, we need to do something with that path. We need to see if that file exists. And if it does, then we of course want to read it. If not, we want to create it and write data to it. So we have two functions here, get links and save links. So let's go ahead and at least stub them out. That way, if we run our application, it will run without any errors. It just won't really do anything, which is perfectly fine for right now. And of these two, the save links function is actually going to be the most simple, because once we implement get links, then everything else is just going to fall into place. So let's talk about get links. Really, the first thing that we want to do is check to see if our JSON file exists. So we can do that with a function called access, and we will import that from the FS module. Now, we can use FS, but we are going to use the Promises API for FS. Now, not every module has a Promises API. However, with every new version of Node, Promises APIs are added to modules. Like, for example, if we take a look at the Calc ECMAScript module, ReadLine. In version 16, ReadLine does not have a Promises API, but in version 18, it does. So newer versions are going to have more Promises API. But thankfully, for our purposes, FS does, which makes sense because we are working with files, and we want to do so asynchronously. So we want to call this access function, but this is asynchronous, so we want to await it. And the first argument that we pass is the path to the file that we want to access. Now, all this is going to do is check if this module can access the file. But there are several different modes that we can specify. Like, for example, if all we want to do is see if the module can see that file, then we can do that. But we can also check if the module can read that file, or if it can write to that file, or if it can execute that file. So there are several different modes that we can check for. In our case, we primarily just want to see if that file exists. So we are going to import another object here called constants. And we're going to use this constants object to specify the mode that we want to use, which in our case is called f_OK. Now, if we wanted to see if we could read to it, it would be r_OK. For writing, it would be w_OK. And for execution, it would be x_OK. We want f. Now, you might think that this access function returns a Boolean value. I would actually prefer that, but it doesn't. If it cannot access that file, then it is going to throw an error. So we need to trap this within a try-catch statement. So we want to try to access the file. If we can, then great, perfect. We can read that file. But if not, then we want to create this file. And so we use a function called writeFile, which we need to import from FS promises. We pass in the file name, which we have with that JSON file variable. And then we want to specify the data that we want to write to this file. So by writing to this file, we are, in a sense, creating this file. And we are providing the initial JSON for that file. Now, by default, this is going to write using UTF-8 encoding. However, if you wanted to specify the encoding, you could pass a third argument. Use the encoding property, and then you could specify your encoding. But for our purposes, the default is perfectly fine. We want UTF-8, so we'll just leave the default alone. So we are trying to access the file. If we can, great. If not, then we want to create that file. We will initialize the data inside of it as a JSON array. And then after the try catch, we're pretty sure that we have a JSON file now that we can read. So let's go ahead and let's read that. We do so with a function called readFile, which we want to import from FS promises. We pass in the path to our JSON file as the first argument. And then for the second argument, we have to specify the encoding because the default is null, which doesn't really make a whole lot of sense to me because if the default for writing is UTF-8, the default for reading should be UTF-8 as well, and it may. However, the documentation says no, so I'm going with the documentation. And then once we have the contents, then we want to return that as a parsed JSON array. So we will call JSON parse, we'll pass in the contents, and then that will give us our array. So once we have a file and everything, we can write to that. We will use the writeFile function once again, passing in the path for our JSON file. But in this case, the data is going to be a little bit different. We want to take the provided links and we want to stringify that or serialize that into a JSON structure so that we can store that within the file. So sounds great. Everything should work now. So let's run this. Node feedreader.mjs. This should create the feeds.json file. It did. We can see that it popped up here in our file list. And if we look at this file, there we have our JSON structure. It's very simple. We have an array that contains the URL that we added to the array. And so that now we can somewhat manage our feeds, we can start focusing on the application code that will allow users to add feeds, remove feeds, and list feeds. We are now ready to start implementing the code for our command line feed reader. And what I want is essentially a command loop, very much like what we did with the calculator, so that we prompt the user to provide something. In this case, it's going to be a command, and then they will provide that command, we execute it, then we prompt them to provide a command again. So since we already have the code to do that, what I want to do is take some of this and extract it into its own module, just so that it makes it a little bit easier so that we don't have to have all of this code inside of our main application file. So I'm going to create a new file. Let's just call this rl.mjs. I would like to call it ReadLine or something like that, but we can't really do that because we have a ReadLine module. And I guess we could, because there is a distinction between just ReadLine and then ReadLine.mjs. But this way, it's very clear that this is separate. So let's go to our calculator, and we want the import statements. We want to create the ReadLine interface object, and we need the question function as well, because we are going to export that question. And we should also provide a way to close the ReadLine interface. So we can export another function, which we could just call close. I think we should probably name it something a little more unique, but close is going to be fine. And this is just going to call the close method on that ReadLine object. So with that in place, we should be able to go back to feedReader, and let's import that. So we have the question function, we have the close function, and that is, of course, from rl.mjs. So that in our application, of course, the first thing we want to do is get the feeds that we are going to be working with. And then we want to prompt the user to provide a command. So we will await question. And as far as the text is concerned, we can just say enter command, and it would be nice to provide a list of the commands that they can provide us. So let's have a list that would display the list of the feeds that we have. The add command would add a feed. Del for delete would delete a feed. Then we would need one to read that feed. And then finally, we need some way to quit the application. So that is what we will prompt the user. And then we will just use a while loop that will execute for as long as input is not equal to quit. And let's go ahead and let's refresh the value of that inside of the while so that we have the loop primed. Then we update input again. And then I guess we can await save links outside of the while loop, and then we will call close. Okay, so now we just need to talk about these commands. Now, the list command should be fairly straightforward. That will just display the list of feeds that we have, so that's going to be easy. The add command really is going to have two pieces. We have the command itself, which is going to be add, followed by the URL. So there's going to be two pieces there. And really the delete is going to have two pieces as well, but it's not very user-friendly to say delete this URL from the list. So what we could do is whenever we list the URLs, we could include the index so that the user can provide the index whenever they want to delete a particular feed, and that would be nice and easy. And we could do the same thing for the read command. We could read, they can provide an index, and then we would just display the headlines or something like that. We don't really need to do anything overly complicated. So let's start with list, because this would be the easiest thing to do. However, we do need to be aware that the command that the user is going to provide might have two pieces to it. So let's take the provided input and let's split it on a single space. That way we can get two pieces, the command to execute, and in the case of add, delete, or read, that second argument there. So let's call this simply command parts. And let's take the provided input. Let's trim it just so that if there's any preceding or trailing white space, we can get rid of that so that there's no irregularities there. And then we want to split it on a single space. And let's also make our lives a little easier. And let's just say that the command that we are going to be working with is going to be from the index of 0, because regardless of what the input is, we should always have something at the index of 0 after we call split. It will be questionable if we have something with an index of 1, but we'll get to that. So first is list. So if command is equal to list, then we want to list all of our feeds. And we can do that very easily because we have our feeds. We can call the forEach method, and we want to output the URL as well as the index. So we can do that inside of console log. And we will start with the index. Let's use a tab, and then we will display the URL. I think that should be fine. And we can test that, but let's implement something else first. Let's implement the add method. Now, the add method is going to be a little bit more involved because not only do we need to get that second part of the command, but we need to be sure that there is something there to work with, because if not, then, well, the add command isn't going to be very useful. So let's check our command parts. Let's see if its length is less than 2. And if it is, then we want to display a message to the user that says, hey, you need to provide the URL. So we could just say that, please include the URL with the add command. I think that's going to be just fine. But if we have two pieces, or at least two pieces to work with, then all we really need to do is push in that second piece. And we get that from our command parts array. And that should be good enough. Well, I say good enough. This is still very naive. There's a lot of other checks that we should be doing, but for the sake of this example, that's going to be okay. So I think we have enough here to at least check to see if this is going to work. So let's run our application. And we should be prompted to enter a command. Let's start with list. And there we go. We see that we have one item. It has an index of 0, and the URL is tuts plus. Of course, that's not an actual feed, but we'll get to that point at some time. So now we want to add, but let's first of all check to see what happens if we just input add with nothing else. We see that we get a message, please include the URL with the add command. Let's do add space just to make sure that we still get the same results, and we do. And that's good, and that is why we wanted to trim the input just so that we can normalize that string. Okay, so now we want to add something. So let's add a URL. Let's just do google.com, and then we will list. And there we go. We now have 2 URLs inside of our feeds, and that's perfect. And whenever we exit the application, that's when the contents of the feeds array is going to be written to our file. So if we take a look at feeds.json, we should have 2 entries now, and we do. So our application is working as it should. We just need to implement a few other things. Like for example, let's go ahead and do the delete command. And let's just copy and paste what we did for add, because this is going to be very similar, except that we want to not include the URL, but we can say, please include the index of the URL to delete, and that will be fine. Now, since we are working with an index, we probably should check to be sure that it is a valid index. However, what we have right now as far as the index is a string, so we need to parse that into a numeric value. So let's just call parse int, and we want to parse the command parts index of 1, so that then this gives us a numeric value that we can check. If index is greater than -1, which is good, and if index is less than feeds.length, then great, we want to delete that. And the easiest way to remove an item from the array is to use the splice method. We pass in the index. We want to splice out that one element in the array, and that's great. However, if the index is out of range, let's display a message to the user. And we'll just say that the provided index is out of range. So let's test this so that in the next lesson, we will include all of the HTTP stuff. So list should still work. Of course, we didn't change anything as far as list and add is concerned, but we can see here the indexes of the URLs. So we want to remove a particular feed. Let's first of all be sure that we get our error message whenever we just use the delete command with nothing else. That is the case. Let's go ahead and include a space after. Once again, we see the same result. Let's specify an index that doesn't exist. Let's say that we want to delete the feed at index 10. We get the error message. The provided index is out of range. So, okay, let's delete the Google entry. So we will delete with the index of 1. Let's check our list. It was deleted. So now whenever we quit, the new contents of the feeds array will be written to the feeds.json file, and we have one entry there. So in the next lesson, we are ready to start working with HTTP requests because we need to be able to retrieve the feed so that we can then display its information. The last piece of functionality that our application needs is to fetch the feed, parse the contents into a JavaScript object so that we can then display the headlines. And really, the package that we are going to be using to parse the feed into a JavaScript object does everything for us, or at least it can do everything for us. However, where's the fun in that? Let's make our own HTTP request so that you know how to do that, and that you will know that you don't want to do that using the built-in HTTP or HTTPS module. So when it comes to working with HTTP or HTTPS, we have two modules, HTTP and HTTPS. I'm saying HTTP quite a bit, but you use the appropriate module for the appropriate protocol. Since most things are HTTPS these days, that is what we are going to be using. However, the way that you make a request and the way that you work with that data is essentially the same, because ultimately what these modules give us access to is the response stream. So we get to read the stream. Let's first of all import HTTPS from the HTTPS module, and then let's scroll on down to start implementing our code. So of course, the read command is going to have two pieces, the command itself followed by the index. We will worry about that later. Let's just focus on making a request first. So to make a request, we use our HTTPS, and then we call the get method. And that sounds great. And I'm going to use the URL for the Node subreddit's RSS feed. I would use Tuts Plus. However, they use Cloudflare in order to verify the connections and add a little bit more security. And so we don't really get the RSS feed. We get the HTML from Cloudflare. So this will give us an actual RSS feed. So whenever you call the get method, you supply the URL, and then you supply a callback function that is going to work with the response. Now, as I mentioned, the response is a stream, and we have worked with the stream. If we open up the original calculator, the standard input is a stream, and we used the data event in order to read that stream. So we essentially need to do the same thing with the response. However, it's going to be a little bit more involved because remember that this is a stream. It is reading the data in chunks. So that typically means that we are going to have multiple chunks and we need to essentially keep track of all of the chunks that have been read. So let's create a variable called content and we will initialize it as an empty string. And then we will listen for the data event on the response. The callback function for this event listener is going to receive the chunk so that we can concatenate that chunk with the content. And that's all well and good, but that's not enough because we need to know when the end of the response occurs. So we need to listen for another event called end. And we don't really care about anything that would be passed to this callback function. Instead, we want to do something with the content because at this point in time, for the end event, we have all of the content. So we can just write that out to the console. There we go. So if this works, we should see the content of the Node RSS feed from the Node subreddit. So let's run our application. Let's run the read command. And, well, it looks like nothing happened. And that's because I have an error right here. Well, it's not necessarily an error. It's a logic error. We want to take the chunk that we received and then add that to content. So with that in place, let's restart the application. Let's call the read command, and there we go. That's less than ideal, especially because we got this information after we were actually ready to move on. If we scroll on up, that's a lot of content. So here we can see right here, we of course call our application, we say read, but notice now we are being prompted for the next command, but then the application writes out the content. So we are getting the content after our loop increments again, and we don't want that. But we also don't want this anyway, because who wants to type all of that out? Who wants to convert this into using the await syntax, which eventually will happen, but we're just not there yet. So instead, thankfully, there are so many HTTP clients available that we can use, and probably the best one is called Axios. And we are going to install that so that we can use Axios within our application. So to do that, we need to go to the command line. We are going to use npm node package manager, and we are going to install Axios. But we also want to use this save, and this is going to install the Axios package for our application, which means that we get to use it, and it has a wonderful API. So let's get rid of all this. Or I guess we could leave it and comment it out, but no, that just muddies things up. So let's get rid of that. Let's get rid of the import of HTTPS because we are going to import Axios from Axios. And let's go back to the read command because now we can do this. We can get the response and we can await Axios.get. We need to pass in the URL of our feed. So let's do that. And this response object is going to have a property called data, and that is going to be our data. We don't have to do anything else. We don't have to read the response stream or anything like that. This just gives us the response and the data to work with. So we can simplify this a little bit by destructuring response here so that we get the data and we can simply write that out to the console. So let's do that. Let's go back to the command line. Let's run our application. We will call the read command, and there is all of the content. But notice now, yes, we have all of the content, but we got the content before the loop finished that current iteration and went on to the next one to prompt the user to enter a command. So this is the functionality that we want, and that's perfect. So now we just need to take this data and we need to parse it into a JavaScript object that we can use. So let's go back to the command line, and we are going to install another package. It is called RSS parser. So let's npm install RSS-parser. And then while that installs, we will go up to the top of our file and we will import parser with a capital P from RSS parser. And what we need to do with this parser object here, this is actually a constructor function so that we can create a parser object. So let's go back down, and we are going to use this parser to create our feed. And we will do that using the parse string method. Now, right here, we can see that there is a parse URL. Remember that I said that this library can do everything for us. So we could have made things a little bit easier on ourselves and just use parse URL. But also, as I mentioned, what's the fun in doing that? So we have our data, and we are going to pass the data to parse string. This is going to give us a feed that has some items. The items are the individual articles. So this is an array, so we can use for each. And for each item, we essentially want to display the headline, and we get that using the title property on each item. So there we go. Let's run our application. Let's call the read command. And we're still outputting the data, aren't we? So we got a lot of information there, but you can see once the markup stops right here, then we can start to see the individual headlines. So why choose Nest.js as your backend framework? I don't know. That might be interesting to look at. Node server upload handling, blah, 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 blah. So we can see that this is working, and that's great. So now we just need to actually implement the read command so that we can work with the index. Let's first of all take this URL. And while we could use our application to do this, I'm just going to modify the feeds.json file so that we include this RSS from Reddit. And we essentially want to start off the same way that we did with delete and add. We want to check how many parts are in this command. Our message to the user needs to be a little bit different. Instead of delete, we'll say to read. But if we do have an index, we do need to parse it into a numeric value. We need to check to see if that value is in range. And if it is, then we will simply fetch the feed, parse it, and then display the contents in the console. Otherwise, we can use the message that we already have. The provided index is out of range, and everything else should work just fine. Let me make sure that I don't have any syntax errors, and I think we're good. So let's give this a whirl. Let's go to the command line. Let's clear the screen, and we want to run our application. So we want to read. But if we just say read, we need to provide the URL, or at least the index. So let's get a list. We only have one, so we can say read, well, let's say read one. We should get the error that the provided index is out of range. So now we have 0, and there we have the headlines displayed in the console. So I guess there are essentially 3 things to take away from this lesson. First of all, don't be afraid to use third-party packages or modules. They exist for a very specific reason. It's because the functionality that is built into Node either doesn't exist or it leaves a lot to be desired, like the HTTP module. Second, if you need to make HTTP requests within your applications, use Axios. It is so much easier to work with. And then third, if you use a package, be aware of its features and the functionality that it provides. As I mentioned several times, the RSS parser package would actually do all of our work for us. So ultimately, that is what we would want to do because, well, it makes our lives easier. But for the sake of this lesson, it kind of made sense to make our own request. The current implementation of our feed reader works, but it is very reminiscent of an environment that is not event-driven. And Node is an event-driven environment. In fact, we saw that at the most basic level with our first calculator application, because we used standard input, and in order to get the input that was typed into the console, we had to listen for an event called data. So even at the most basic level, Node is an event-driven environment. It's just that there are modules and APIs that provide a higher level, making it easier to do those things. So what we are going to do in this lesson is essentially rewrite our feed reader, but we are going to do so using our own custom events, because every object or class that emits an event throughout the entire Node platform inherits from a class called event emitter. And the awesome thing about this event emitter class is that we can use it within our own applications to emit our own custom events. So I'm going to create a new file called feedreader-evt, and we can start by essentially copying all of the code from just feedreader and pasting that inside of this new file. Now we need to address our readLine module, because what we have here is something that was very useful for the original feedreader. But by taking an event-driven approach, we have to think a little differently. Like, for example, we can't really use a while loop or anything like that because some of the things that we are doing are asynchronous, and we need to rely upon those processes finishing before we prompt the user again. So what we are going to do is use our readLine interface object. We are going to export this because if you'll remember, whenever we first talked about the question method, I said that we could emulate the functionality of question by using some other methods from our readLine object. Well, we are going to do just that. So we aren't going to use question here. Instead, we are just going to use that readLine interface, and we are going to write a helper function simply called prompt. And inside of this function, we are going to use our readLine interface. It has a method called setPrompt. This is essentially going to set the text that the user will see in the command line. This is what we are going to prompt them with. So we just want to use that text of enter the command and then provide the list of commands. But then we want to call the prompt method, and that is going to prompt the user and wait for them to provide some input. And whenever they provide the input, whenever they type something and then press the enter key, that is going to emit an event on our readLine object. That event is called line. So whatever the user types and presses enter, that entire line is going to be provided to the callback function. So that's where we are going to get our input. And so inside of this event handler, we essentially want to break up our command into those two distinct parts. So let's go ahead and bring that code on over. But then we could do something like this. We can emit an event that is the same as the command itself. So we would have an event called list and add and read and quit. And then we would pass any data that that command would need. So in the case of add or delete or read, it would be the second part of the command. So first things first, we need to import the event emitter class, and that is from the events module. And then the next thing that we need to do is create an object of type event emitter, because this is what we would use to emit and to listen for those events. I'm just going to call it emitter, or let's call it emitter, and let's new up the event emitter constructor so that inside of our line event handler, what we will do is use the emitter object. It has a method called emit, and then the name of the command is the event, and then any other data that we need to provide with that event that will be passed to the event listener comes after that. And it can be any list of arguments. So it can be one argument, it can be 10. In our case, it's simply just one. So that's what our code is going to look like. And the easiest thing to implement first is going to be the quit event. So let's do that. We will use the emitter to listen for the quit event. There is no data provided with this event. So all we need to do is save our links and then close the readLine interface. So we can take that code out, we will paste it in, and that's all that we need to do, although we do need to make this callback function asynchronous. Let's comment out the while loop. But before we run this, we do need to call prompt because we need to prompt the user. So let's go ahead and let's do that. Let's save it. Let's go to the command line and we will run this. We will be prompted to provide a command. If we type in quit, it exits. So there we go. The only other thing that we need to do is extract all of this other functionality. So the next easiest thing would be the list event. So let's just copy what we did for quit. Let's paste that in. This is an event that is not going to have any other information because all we need to do is read our feeds, or not read our feeds, but iterate our feeds. And after we iterate our feeds, we need to prompt the user. So the only thing about this particular approach is that for every one of our events, except for quitting, we will need to call prompt, because after we do whatever that event needs, we need to prompt the user to enter another command. So let's just do a sanity check. Let's run our application. Let's run the list command. And there we see our list. So that's fantastic. Let's quit. And then let's implement the other commands. And I guess we could do add. That makes sense. This is going to receive a URL. However, we need to check to see if we actually have a URL, because the user could just type the add command and nothing after it. So let's check if URL is undefined. And if it is, then we want to display a message to please include the URL. I mean, that is essentially what we did before, except that we checked the length of the command parts. Now we are actually checking the value itself. So if URL is undefined, please include the URL. Otherwise, we want to add it to our feeds. So this is going to be just a bunch of copying and pasting and making the necessary changes. So in this case, we need to push in the provided URL. So that's good. We could check that functionality, but let's move on. That should work. And of course, we will definitely try it, but it will be a little later. So now for the delete command, that is going to accept the index. But once again, we need to be sure that we have an index. And at this point in time, the index is a string. It is not a numeric value. So really, we just need to check if it's undefined. Well, actually, we need to do other checks, but for our purposes, checking if it's undefined is going to be fine. And let's just copy code and paste code. And let's copy some more and paste some more. Of course, we need to modify this code just a little bit, because this code does take the provided input and it does parse that into an integer. So here, all we really need to do is get rid of the let keyword. I think everything else should be fine, although we do need to pass index to parse int. That looks good. So let's just copy, paste. And the only other command we have is read, which is going to be very similar, except right here, where we actually want to read the feed. So let's paste in that code. We need to uncomment some of it. And I notice that I never changed this code. The URL was hard-coded here to get that. So we should go ahead and change that so that we get the appropriate feed at the given index. We do need to change this text. We want to read, not delete, and that should work. So let's run it. Let's see what we get. Okay, we know that list and quit work. So let's add a URL. This doesn't necessarily need to be a real thing. We just need to check the functionality to make sure that it is going to add that URL, and it does. We want to delete. Now, let's not pass anything for delete. Let's just specify delete, and we get our error message. That's what we wanted. We want to delete index 1. Let's list again. Great. So now let's read 1. And of course, that's out of range. We want to read 0. That should fetch the feed. We see the titles, and we are good to go. So now we can quit, and that's it. And so, of course, the thing to take away from this is that, first of all, Node is event-driven. At the most basic level, it uses events. And everything in Node that does really anything, if it reads data, if it writes data, if it works with a stream, it inherits from event emitter. And event emitter is something that we can use within our own applications to make them event-driven as well. One of the fantastic things about Node is that it can function as a full-fledged HTTP server, and it is completely independent from any other HTTP server software that you might have on your system. So if you have Apache or IIS or anything else that will handle HTTP requests, this would be completely separate. So this means that you can build a Node application and you can run it on any system. The only thing that it needs is Node installed. So starting in this lesson, we are going to look at how we can build HTTP applications, or basically web applications, using Node. So I've created a new directory. I've called it Node HTTP Server. You can call it whatever you want. I do recommend that you keep this separate from the Node apps directory that we have been using over the past few lessons. And the first thing that we are going to do is create a package.json file. We do this by using npm init. Now, if we were to run this as is, it's going to ask us several different questions, and I don't have time for that. So most of the time, whenever you create a package.json file, you will use the -y flag. This is going to essentially set everything using default values. So here we can see the JSON structure that is actually output and stored inside of the package.json file. Just about every one of these properties is a prompt, and we would have to answer those. So it just makes sense to say -y and be done with it because, well, nobody's got time to answer however many of those questions there are. Now, you might ask yourself, what exactly is a package.json file? Well, it is the file that sits at the root of a Node application, and it contains all of the metadata that is relevant to the application, such as the name, the version. There are scripts that you can define. Whenever we install dependencies for our application, they will be listed here. And there's a lot of other things that package.json gives us. But basically, this is saying that this directory and the code inside of it is some kind of application. Now, I want to point out that there is a main property here, and it is set to index.js. This is to signify that the main file for this application is index.js. So let's create that file so that we can start writing our server application. I am, however, going to change the extension to MJS. All right, so we want to create an HTTP server, and we do that with a function called createServer that we import from the HTTP module. Or if we were only going to work with HTTPS, then we would import that from HTTPS. Since that requires a certificate and stuff like that, we're just going to stick with HTTP. And so the first thing that we need to do is create that server. So we want to store this in a variable because after we create the server, we want to start our server listening for incoming requests. Now, we pass a callback function to the create server. This function has two arguments, request and response. And for right now, we aren't going to do anything inside of this function because we need to listen for incoming requests. And the first argument that we pass is the port that we want to listen on. Now, if we have other HTTP servers on a system, we want to stay away from the defaults like 80 or 443. So you might want to use something like 8080 or 8888 or something along those lines. I don't have any other HTTP software running, so I'm going to be lazy and just use the default, 80, because when it comes to the browser, I don't want to specify the port. That's just me. I'm going to be lazy. So the second argument that we pass to listen is a callback function that is going to execute when the server is actually listening. So here it's useful to display a message saying that the server is listening, and it wouldn't hurt to also say where it is listening. So let's say that it is going to be at localhost, and just for kicks, let's include the port as well. We do that using our server object. It has a method called address, which returns a property that has a port property. So with this as it is, let's go to the command line. Let's run node index.mjs, and we see that the server is listening. That's great, actually. So let's open up a browser, and let's go to localhost. And we will see that nothing happens, which makes complete and total sense because our application doesn't do anything. Yes, we have created an HTTP server. We are listening on port 80, but we aren't handling any requests. As you can see, it's just still spinning, and it will continue to spin until we actually do something. So we want to provide a response. And ideally, we would look at the URL and then we would provide an appropriate response to that URL. But we will get there. For right now, let's just write out some text. Since this is our first HTTP server, let's use the good old hello world. So we are going to use our response object. We will call the write method and we will say hello world. So great, let's do that. We need to stop our application so that we can run it again. We can see that the server is running, so let's go to the browser. Let's refresh the page, and it looks like that nothing else is going on. We are still just spinning over here. Nothing is being displayed in the browser. Why is that? Because we wrote something out to the response. And that's all well and good, but we have to signify where the end of the response is as well. It's not enough to just write to it. So we can write to the response, and then we need to end the response. And we can pass in a string that has what we want to send with the end of that response, which means we have to go back to the command line, stop our application, run it again. Then we can hop back over to the browser and we can refresh the page. And now we have hello world. Now, of course, you don't have to write and then call end. If you wanted to build the response all at once, then we could do something like this, where we have our content, we say hello world, and then we can just pass that content to the end method. And that would give us essentially the same result. And that would definitely make it easier whenever we actually respond with an HTML document. But we do need to go to the command line so that we can stop and run our application and then go back to the browser, refresh, and we can see that that actually works because we have that comma now in our text. But let's open up the developer tools here and let's go to the network tab. And we will need to refresh this so that we can see the information about the request. But if we inspect this and we look at the response headers, there really isn't a whole lot here. There is the content length, there's the date, and the keep alive. There's not any content type, and the content type is very important. So let's provide that. We need to provide the content type header, and we do that by using our response object once again. It has a method called writeHead, short for write header. And we specify the status code and then any headers that we want to provide. So we have the content type, and so that is the name of the property in this object. This object contains all of the headers. So if we have multiple headers, we just need to provide the properties where their names are the header names that we want to provide. And in this case, we want this to be text HTML. We should specify the char set as well as UTF-8. And so we will save this. We will go to the command line so we can stop. We can run it again, and then we can go to the browser. That gets a little annoying. And in the next lesson, we will look at a tool that will make that a whole lot easier for us. But notice now that the text changed. We are no longer viewing something that looks like just plain text, and now we are seeing something that is rendered using the default style sheet within the browser. But if we look at the network tab, let's inspect the response. We now have a content type. Everything else we don't really need to worry about. Now let's very briefly talk about writing data to response. Remember I said that this is a full-fledged HTTP server, which means that we can serve more than just HTML or text-based things. If we needed to provide a PDF document, we could do that by writing what's called a buffer, which is just binary data. We can serve anything that any HTTP server can serve. We can also handle any HTTP request that any server can handle. The only issue is we have to write the code that actually does all of that. So Node is extremely powerful in that aspect, but it can also be very time consuming because we start completely from scratch. We have to write everything that we want our web application to do. And over the next few lessons, we will be doing just that. But eventually we are going to reach for Express, which is a framework that makes it easier to build web applications. In the previous lesson, we created an HTTP server that serves some very simple content. And over the course of creating this server, we made several changes to the code. And every time we changed it, we had to stop our application so that we could restart it so that those changes would be loaded and then we would see the result in the browser. And that is rather annoying. Now, it's not something that is specific to Node per se. There are many other platforms where you have to actually build your code before you can run it. But that doesn't make anything better. It is still annoying. So thankfully, we have a tool that we can use called Nodemon. And actually, there isn't any official way to pronounce it. It looks like Nodemon, like Node Monitor. But some people pronounce it as Nodemon. Some people pronounce it as Nodemon. I mean, there's different ways that we can pronounce it. You can choose how you want to pronounce it. I call it Nodemon. And this is a development tool that will watch for changes to our files, and it will restart our application when it detects those changes. So we want to install this. We do so using npm, and we can install it in a couple of different ways. The first is globally, and we use the -g flag to signify a global install. If you install something globally, then it is available for the entire machine. And when it comes to Nodemon, that's typically how we install it. However, we could install it just for this project. And if we did that, we would want to use the save dev flag, because this is a dev dependency, a dependency for development. Now, I'm going to choose this option first because I want to show you inside of package.json how this is going to look. So let's open up that file and we will see right here, there's this new property called dev dependencies. And it is an object where the properties are the dependency names. In this case, it's Nodemon. And then the value is the version that is installed. Now, there are two different types of dependencies. There are the dependencies that our application relies upon to provide some kind of functionality. And then there are dev dependencies, which are dependencies strictly for development purposes. Nodemon is a dev dependency. But as you add dependencies, they will be listed here inside of package.json. Now, I typically don't install Nodemon for a project. So what I'm going to do is uninstall this, and then I will install it globally, because Nodemon is one of those tools that regardless of what I'm doing, if it is a Node application, I'm going to use Nodemon. So let's install it using the global flag, and then we will hop back over to package.json. Notice that the dev dependencies property is not here. Okay, so that's great. Let's go to the command line. And let's use Nodemon. We do so by just calling Nodemon, and we would use this as if we were using the node command. So we would follow this up with whatever file name that we wanted to run. So we are going to run index.mjs, and it's going to watch for changes to our file. So I believe this just says hello world. It does. So let's go to our code and let's modify this so that it says hello node.js. And if we hop over to the command line, we are going to see that Nodemon restarting due to changes, and it's starting our application, and now the server is listening. So we can hop on over to the browser, we can refresh the page, and we will see our new content, hello node.js. So that is a very big improvement. Now, something else that we could do is define a script. Now, these scripts are NPM scripts. They are used to basically run commands that might be a little difficult or a little tedious to run. I'm not going to say that running our application is tedious, but scripts are useful for development purposes. They are also useful for whoever is going to deploy the application. So if we had a script called start, and in order to start the process involved calling node and then the name MJS. And then if there were flags that we needed to supply to it, it makes a lot of sense to just define a start script so that all we would have to do is run that script and then it would run our application. So in our case, I want a script simply called dev so that we can start up a development environment. And to do so, we would use Nodemon followed by the name of the file that we wanted to execute. And if we wanted to have a start script for whoever is going to deploy this, then that would use the node command. And we would follow that up with the name of the file. So if we go back to the command line, let's stop this. In order to run these scripts, these are npm scripts. So we would say npm space run space, and then the name of the command. So dev in this case. So if we ever changed the main file of our application, we could still use the same script. All we would have to say is npm run dev or npm run start, but we would need to modify the script so that it would have the updated file name. Now, there's one other thing that I want to do. We are using ECMAScript modules, and so that means that we are using these MJS extensions. However, I want to not use MJS extensions. I want to use just plain ordinary JS. And we can do that, but we need to add a type property to our package.json file. And the value is going to be module. And we can see that Visual Studio Code is telling us what this is going to do. When set to module, the type field allows a package to specify all JS files within our ECMAScript modules. If it's omitted, then type is assumed to be CommonJS. So I like this approach because, frankly, I like the JS extension, not the MJS extension. So this is a perfect example of why you would want to use a script. All we have to do is modify the script, and we can run that script using the same syntax that we had gotten before. So npm run dev, our application runs. Let's refresh the page. That content is served. So let's modify that content. Let's change it back to hello world. Nodemon sees the change. It automatically restarts our application. And whenever we refresh the page, we have our new content. Let's modify our HTTP server so that we actually return some HTML. And this is going to be a dynamically generated HTML document. So let's start by redefining our content. And I'm going to use a template string for this because we are going to define some data inside of an external file. And we will supply that data inside of our content using template strings. So of course we need an HTML document. So I'm going to paste in a simple HTML document. There is no content here except that the title is already set at guitars. And inside of the body, we are going to have some kind of heading element. It really doesn't matter what it is. I'm going to go with H2 and I'm going to use the text of my guitars. Then we will have an unordered list, and the list items are going to be dynamically generated. So let's create a new file, and this is going to be where our data resides. It's going to be a very simple array where the elements are going to be objects that have a make property and then a model property, kind of like a car, where the make is the manufacturer. So a Fender Strat is made by Fender, and the model is Strat. And let's just create a couple of other options here. So we'll have our Fender Strat, we will have a PRS Starla, and then we will have a Gibson Les Paul. Now we want to import this file into our index file. So let's do that. Since we are exporting the default, we can call this whatever we want. And I'm just going to call it guitars from data.js. And inside of this UL element, that is where we are going to use our guitars, and we are going to call map, and we will provide a function that will essentially take each individual guitar and turn it into an LI element with the appropriate content. So we can just call this create list item, and that will give us an array of strings, and those strings would be the HTML. So we want to output that, and we will join those strings together with a new line. So whenever we look at this in the browser and we take a look at the source code, we will see that the LI elements will be on their individual lines. Because remember, what we are doing here is we are outputting the exact content that is going to be loaded in the browser. So now we just need to define that create list item. So let's do that. I'm going to use an arrow function because this is going to be a very simple function. It is simply going to return an LI element where the text is going to include the make as well as the model. And I guess we could make this even simpler by destructuring that guitar to where we have make and model, and then we can simply use those identifiers here inside of the output. So that should work. That should give us a page that has our list of guitars. So let's go to the browser, let's refresh, and that is exactly what we get. Although let's make this a little larger. So for the body, I'm going to add some style to where the font size will be 2 rem. I think that should be large enough. So if we go back and refresh, okay, there we go. That's a lot easier to read. Well, let's take a look at our source code, and we are going to see what was exactly sent to the browser. And we can see right here that the LI elements are all on their individual lines. And of course, we see that because whenever we joined all of the LI elements together, we did so with a new line. So if we get rid of that and we just join them with an empty string, let's go back to the browser and refresh, we will see that all of the LI elements are in line. So as you can see, our code is responsible and completely responsible for what is sent to the browser. So you want to be absolutely careful when you are working with sensitive information that doesn't leak through. Of course, as it is right now, we don't have that, but it's good to go ahead and start thinking about those types of things. I want to expand the functionality of our HTTP server so that instead of just displaying the list of guitars, each one of these will be a link. So whenever we click on the link, we will see the information for that individual guitar, which we don't have a lot of information, but the idea is that we want to have a dynamic experience. Now, we can accomplish this in a couple of different ways. In modern applications, we would have a URL that was very readable and quote-unquote hackable, so that we would have localhost/guitars, and then we might have an ID or something like that. So instead, we are going to take an easier approach, and we are going to use the query string so that we can have an ID query parameter, and then we can set that to whatever value that we want in order to display that individual guitar. So that means we need to go to our data and we need to add an ID property to each one of our guitars, which this will be very quick and simple. So we will have IDs of 1, 2, and 3 for each one of those guitars. And then we need a link in our markup. So whenever we generate those LI elements, we will have an href. And the value of that href is going to be simply $ID equals, and then the ID. Now we do need to extract the ID like we did for make and model, but there we go. That should give us our links. So whenever we refresh the page, we can see that those links exist. And that's fantastic. But of course, whenever we click on these links, we get the same content. Because remember, the only thing that our server is going to respond with is what our code does, which right now our code simply returns the same content regardless of what that URL is. So of course, the next step is to extract the ID from the URL. Now, the request object that we get has a URL property, but this is not an absolute URL. This is relative. And in fact, it's just the path according to our application. What do I mean by that? Well, let's write this out to the console so that we can see what this URL property actually is. So let's go to the browser. Let's refresh the page here. And then let's go to the console. And we can see that we have two requests. The first has a URL of $ID equals 1. There's no host, there's no protocol, it is simply the path. And then we have the request for favicon. Now that's being done by the browser. There's really nothing that we can do about that. But this is what we get from the URL property. So we could use that and we could try to extract out the value of ID. That requires doing some string manipulation that I just don't want to do. Thankfully, we can use a URL object. And we have to create this object. So let's do that. We have a URL class. So we will new up the constructor. The first thing that we pass is the URL that we want to work with. So that is our request URL. But remember that this is not an absolute URL. What we need to do is also provide the base URL that will make an absolute URL, if you get my meaning. So what we need to do here is provide the protocol, the host. If we had something other than port 80, we would need to include the port. And if there were any other segments in the URL that serves as our base URL, we would need to supply those as well. We don't, because our application runs at localhost. So that's all well and good. So now we have this URL object that has a property called search params. This has a method called get, and then we simply pass in the query parameter that we want to get the value for. So let's write this out to the console and let's see what we get. So whenever we have a page that has an ID parameter, whenever we look at the console, we will see that value. Perfect. That's exactly what we need. But notice that we also get null. Now, this second request was for the favicon. And because it did not have an ID query parameter, of course, there's nothing there, so it is null. So we essentially need to change our code so that if we have an ID query parameter, then we need to change what we show inside of the body. Otherwise, we want to display our list of guitars. So we can do that in a variety of different ways. I'm going to take the more straightforward approach, and we'll just have an if statement. If we have an ID, then great, we show this. If not, then we show our content. So let's create another function. We'll call this simply create list because we already have a create list item function. And this is going to return the content that we generate, basically everything inside of the body. So let's do that. And then let's create another function for get guitar content. I'm sure that there's a much better name that we could give that, but that's going to be okay. So in this case, we want the ID because we need to know what guitar that we want to get. I'm going to write this as just a normal function. So what was that? Get guitar content. And we had the ID. And the first thing we want to do is find the guitar with that given ID. Now, of course, we need to do several checks and all of that stuff. I'm just going to be lazy here. And we are going to try to find the guitar that has the given ID. And I guess we should be somewhat good here and check to see if we have a guitar. And if so, then we will simply return the information for that guitar. Let's just have an H2 element where we display the guitar make and the guitar model. Otherwise, we want to display some information that the guitar doesn't exist or something along those lines. So let's just have a P element, guitar does not exist. Very simple there. So now, whenever we generate our content, we can do something like this. If we have an ID, then we will use get guitar content and pass in that ID. Otherwise, we'll simply create our list of guitars. That should work. So let's go back to the browser. Let's refresh. Now, the URL is already looking for an ID of 1, so we should have seen the guitar page there, but something went wrong. And if we take a look at the console, then we will get an error message here. So we can see that the reference error ID is not defined. Well, of course, it's not defined because we didn't create it, did we? No, we just wrote something out to the console. So let's get that value. Now, one thing to note before I save this, if you read all of this information, at the very bottom it said that the app crashed, waiting for file changes before starting. So whenever I save this, it's going to automatically restart our application. And looks like that there was another issue. So I have an error right here. Instead of guitars, I had guitar. So let's go back. Okay, so now there are no errors. We can go to the browser. Let's refresh the page. And here we see the text for our guitar. That's great. We can go back and let's just go ahead and hit refresh here. And we see Gibson Les Paul, ID of 2. Let's refresh. We see the PRS Starla. Let's keep going back until we get to the list. There it is. So let's refresh here. We can click on any one of these links and we can see that we get the content for those individual guitars. But let's also test when the ID doesn't exist. So if we try an ID of 10, that guitar doesn't exist. So we should get the text, guitar does not exist. And so that's perfect. So now we have some actual functionality with our page. It's getting a little cluttered because of all of the functions that we are writing to handle the different circumstances. And in the next lesson, we are going to add a little bit more functionality by looking at the URL and parsing out different pieces. Let's add the ability to delete a guitar to our application. And we need to talk about how we are going to allow the user to tell our application, hey, I want to delete a certain guitar. Well, when it comes to web applications, the HTTP request is the user input. And one of the key components of the request is the URL. Now, one thing that we could do is use the query string. We could have something like an action variable to where the value would be whatever action that we needed to execute, such as delete or add or something like that. And that was very popular in the 1990s, especially in PHP. Of course, Node didn't exist back then, but that pattern was very common. But now it's not so much because we can have pretty URLs. So what I want to do is have a URL where the first segment is going to be delete, followed by the ID that we want to delete. So we need to write the code that is going to handle that particular situation. And we can do that by using the requests URL. Now, in the previous lesson, we used the URL class. We created a new URL object, and that allowed us easy access to the query string. We don't necessarily need that because the URL itself is just a string, so we can parse out the information we need by using simple string methods. So let's create a variable called parts, and we will take the URL and we are going to split it on a slash. Now, if you'll remember, whenever we looked at the URL in the console, it always begins with a slash, even if we make a request for the root of our application, which for us is just localhost. The URL is still a slash. So in the case of /delete/ID, we will essentially have three parts. The first part is going to be an empty string. The second part is going to be delete. The third part is going to be the ID. So that's the index 0, 1 will be delete, index 2 will be the ID. So we're going to take a naive approach here, because if we wanted to do this correctly, it would require quite a bit of code. And that's just the nature of building a Node application from scratch with no frameworks whatsoever. We have to write the code to handle everything. So all we are going to do is check to see if delete is included in any of the segments. Ideally, we would check the position of the segments. If it is at index 1, then that's what we want to do. But we are going to keep this simple. And whenever we have delete inside of our URL, we want to delete that provided guitar. So we'll have a function called handleDelete that we will pass the ID to. So that would be parts at index of 2. But then we need to redirect, because when it comes to doing something like deleting, there is no content that we need to send to the browser other than a redirect. We want to tell the browser to redirect back to the main page. So we are going to write a function called redirect. And in order to redirect, we need access to the response object. So we will pass response to this redirect function, and then it would be nice to specify where we want to redirect to. Now, we could define the redirect function so that it always redirects to the root of our application, but I think it would be much more useful if we can pass in where we want to redirect to. So if the URL does not have delete, then we want to do what we have been doing, and that is simply displaying the appropriate content. So there we go. That is our code. We just need to implement that. So handle delete. Let's scroll on down. This file is getting a little unruly. When it comes to writing Node applications, I like my main file to be as clean as possible. So ideally, I would put these helper functions inside of their own respective files. Like, for example, I would have a file for create list and create list item because those things are similar. And in fact, one is a dependency of the other. So I would just extract that into its own file. The same would be true probably for get guitar content as well as for handle delete. But for now, this is going to be fine. So whenever we want to delete a guitar, we want to find the index of that guitar. And we can do so using the array's find index method. So we want to find the index of the guitar that has an ID equal to the given ID. And then we want to remove that guitar. And we can do so using splice. We'll pass in the index and then 1. Now, once again, this is naive. Index could be -1 because we could supply an ID for a guitar that doesn't exist. We're not going to worry about that. In fact, let's just add a to-do. So check index. There we go. That way we know that we have some work to do there. So there's the handle delete function. Now we need the redirect. So let's define that. And we get the response as well as where we want to redirect to. And in order to get a browser to redirect, we have to set the location header. So we are going to write a header. The response code is going to be 302. That is a redirect code. And then we want to specify where to redirect to. And we do that with the location value. It wouldn't hurt to also specify the content type because typically there is some kind of message provided when there is a redirection. Like, for example, we can just have some simple text that says redirecting to and then the URL that we are going to send the user to. So let's do that. We'll have redirect to, and then we will include that URL there. So there we go. That should work. Let me make sure I haven't forgotten anything. We are checking if we have delete in the URL. If we do, we handle delete, then we redirect. Otherwise, we do what we did before. Should work. So let's go to the browser and let's give this a try. Oh, we need a link, don't we? Let's go down to the get guitar content. And whenever we display the make and the model, let's put this on another line so that we can have a P element. And inside of that P element, we will have an A element where the href is going to be for /delete/ and then the ID. And then we will simply have the text of delete. So that's all we need there. Let's go back to the browser. We don't need to refresh anything because we are going to navigate to the page and there we can see the delete link. So if we click on this, it should delete the Fender Strat from our guitars array and it should redirect us back to the main page. And it does. There we go. And we can delete each one of these guitars. That's fantastic. But now we don't have any guitars to list, and it would be nice to have the ability to add a guitar. So in the next lesson, we will add that functionality. Now that we have the ability to delete guitars, we need to be able to add them. But before we can actually add them, we need a form so that the user can fill out the form, submit it, and then we can process that information. So we need to decide, first of all, what URL we are going to use to display the form. And I think just simply /add will be fine. So that's what we are going to run with. Now, when it comes to handling different URLs, I guess we need to decide how we are going to structure this code. Because as it is right now, we essentially have two types of URLs. We have one that doesn't really provide any content. It just does something. It processes data. And then we have one that actually returns content. So I think what we can do is, while yes, it's great that we still check to see if we have delete inside of our URL, we want to put everything else inside of this else block, including a check to see if we have add in our URL. But before we get too far into that, I also want to restructure this, because now is a very good time to start to extract some of this functionality, especially when it comes to generating content. So I think what I'm going to do is create a file called simply content.js. And inside of this file, we will have all of the helper functions that we will use to generate content. Ideally, we would separate these into their own files, at least according to what kind of content that they were providing. But I think for the time being, it's going to be fine just to take everything out and put it inside of content. So let's do that right fast. As far as exporting is concerned, we only need to export the create list function, and we also need to export the get guitar content. Now, we also need to talk about how we are going to work with the guitars array inside of this file. Do we go ahead and import that, or do we simply provide the data that we want to display? And I think I like the latter option, so that this create list will accept the guitars that we want to display. And that way we don't have to worry about importing any data or anything like that. And we can essentially do the same thing for the get guitar content. We could say that index.js is going to find the guitar and then provide that guitar to this function. That way we can keep the code for this essentially the same. We just need to make that modification to where we say guitar.id instead of just ID. And this should be okay. Now, of course, we need to modify our index.js file in that at some point in time, we will need to get the guitar by its ID. We will talk about that here in a moment. Let's first of all import all of those things from our content. So that was the create list function. That was also the get guitar content function. Those are coming from the content.js file so that we have access to that. Then inside of this else, we will start our checks. So we still need the URL object. We still need to see if we have an ID, and then we will start our checks. So if the parts includes add, then we want to generate a form that we will then display within the page. So let's also do this. Let's create a variable called content. We will initialize it as an empty string. And for this add URL, we will simply say that content is going to be the result of calling get form. Else, if we will check to see if we have an ID. And if that's the case, then the content is going to be calling get guitar content, passing in the guitar. So that is where we will put this code here. So we don't need to make this a constant. We can just use let here. So that will take care of when we want to display the content of an individual guitar. And then finally, we want to display our list. So we will call create list. We will pass in the guitars, and that should be fine. So at the end, we will write out that content to the response. And really, I want to do this as well. I want to take this HTML. Let's just take that out. Let's put this inside of content as well. And I want a function that we can call that is going to take the body that we are going to put into the HTML body and then return the entire document. So it would look something like this, to where we can call it view, and then it's simply going to be a string to where right inside of the body, we output the content there. Now, we also need a form function, don't we? What do we call that? That was get form. But before we define that, let's go ahead and let's say that whenever we end the response, we're going to send the view passing in the content. That's going to generate the HTML document that's going to be sent to the browser. So we've got that taken care of. That's fantastic. We do need to import that. And let's go ahead and let's also import this get form function. Even though it doesn't exist yet, it will here in a few moments. Now, as far as the form is concerned, this is going to be a very simple form. In fact, I think I just might go ahead and just paste it in, because the majority is just markup. So we have a form. The method is going to be post. The action is going to be to /add. Or do we want to change that? Let's say to /save. I think that would be better. Then we have our fields, one for the make, one for the model, and then we, of course, have the button that will submit the form. So with that in place, let's go back to index. Let's make sure that we are covering all of our bases. So if we are going to delete a guitar, then that code is going to be just fine. Otherwise, we are going to provide data that is going to be loaded into the browser. So we are writing the 200 response, the content type, we get the URL, we get the ID. We check if the URL contains add, and if it does, then great. We show the form. If not, we check if the URL has the ID query parameter. If it does, great, we get that guitar, we show that content. If not, great, we show the guitar list. Okay, so that should be fine. Let's do one other thing. Let's go back to content. We need a link to go to our add form. So let's do that here inside of our create list. So we will have the title of my guitars. Let's put this on another line. And then we will have a link inside of this H2 element that will go to simply /add, and it will be add new guitar. So that should work. Let's go to the browser. Let's refresh the page. We have our guitars. We have the link for add new guitar. Let's make sure that all of the other things work. So we're going to view the individual pages. That works fine. Let's delete one. That works fine. Let's go to the add form, and that works fine. So in the next lesson, we need to process the data that is submitted using our add form. Our application now has a form that the user can fill out and submit in order to create a new guitar. Now, this is going to generate a post request, and a post request is very different from the get requests that we've been working with thus far, because a post request has a request body. It has all of the information that the user provided whenever they submitted the form. So this means that we need to check what kind of request has occurred, because it makes sense to start dividing our code into those different types of HTTP requests. So we can use the request object. It has a property called method, and this returns the type or the method of the request. Now, the method is going to be in all uppercase. So if it is a get request, get is all uppercase. In our case, it's a post request. Now, if it's not a post request, we are going to assume that it is a get request. That's a fairly safe assumption. In a real application, we probably wouldn't want to do that, but for our purposes, this is going to be fine. Now, we can't just get the request body. It's not given to us because the request is a stream. So the data is being streamed from the browser or the client to our application, which means that we have to read that stream. And we can keep track of the data that we have read in a variable that I'm going to call body. Now, in order to read the request body, we need to listen for an event on the request object. It's called readable. And this event triggers when the request is received by our application. So whenever the request is available, this readable event occurs and we can start reading data here. We do that by using the read method on the request object. Now, it's possible that the data is null. So we need to take that into account. Let's check if it is not null, because if it's not, then we want to add that data to our body. Otherwise, we just want to ignore it. But that's not enough. That's just reading the data. At some point in time, we are going to reach the end of the request body, in which case we want to listen for the end event. Because when we get to the end event, then we have all of the data that we need. We just need to parse it into something that we can use. So let's do this. Let's write out what we have in the body. And we are going to see that it is a URL encoded string that has all of our information. So for the make, let's say that we want a Gibson, and then the model will be a flying V. So we will save that. Let's take a look at the console, and we will see our data right here. It is URL encoded, so it looks like a query string. So we need something that is going to parse that into a JavaScript object that we can use. And we have a module that does just that. It's called the query string module, and it has a parse method. So we want to import this parse function from query string. And we can use this to parse our body into a JavaScript object. And the properties on this JavaScript object are going to be the field names that we had. If we take a look at the content and the getForm method, the names of the fields was guitar_make and guitar_model. If we take a look at the console, that is what we get, guitar_make, guitar_model. Our object is going to have those properties, which means we can't just take that information and just pass it on. We have to essentially create a new object. But we will create a guitar object by parsing the body. And then we could do something like this. We could push in a new object to the guitars array, but I don't necessarily like that. For one, because we have to specify an ID. And inside of our data, that was hard-coded. We need something that's a little more dynamic. And for two, I don't necessarily like that our server itself is manipulating our data. Instead, I think it would be better served to modify what we export from our data module so that we could have a function called getGuitars, which returns the guitars array. Then we can have one called saveGuitar so that we could pass in that guitar information and it would save it. So the code would look something like this, so that we would call saveGuitar. We would pass in an object that has a make, which will come from guitar_make, and then one for model. And then this saveGuitar function will be responsible for adding the ID and adding it to the guitars array. So since we don't have that guitars variable anymore, I'm going to modify this so that we get our guitars by calling the getGuitars function, which means that we need to go to our data file and make several changes now. So this is just going to be a constant guitars, which we will set to that array. We need to export a function that will simply return that array. That was called getGuitars. We also need to export a function called saveGuitar that is going to receive a guitar object. We need to generate an ID. So let's say that we will have a function called newID, and then we want to push that guitar into the guitars array. So that's what that would look like. Now we just need to define that new ID function. So we can have a variable called ID, which will keep track of the last ID that was generated. Then we can have a function called new ID, which is simply going to return ID++. And so we can use this new ID function whenever we create our guitars here, and that should work. So let's give it a whirl. Let's go to the browser. Well, we have an error somewhere, so let's take a look. Okay, it was just from our other code. So we should be able to just refresh this in the browser, and it should be able to resend this form. And you know what? We're not doing anything whenever we save it. So let's do this. Let's go to localhost. Okay, we see our Gibson Flying V. So the code for processing the form and saving that information does indeed work. We just need to redirect back to the main page after we save the guitar. So inside of the end event listener, we will call the redirect function. We will pass in the response, and we want to go to the main page. So with that in place, we should be able to add a new guitar. We want a PRS McCarty, and voila, everything works. Now, of course, the Gibson Flying V that we added earlier is no longer there because as we made that change to our code, Nodemon restarted the process. And since we don't have a real data store, everything is stored in memory, we lost any changes to the guitars array. So our application is still working just fine. Or no, it's not, because delete didn't work. So let's take a look at the console. Let's see what error we have. Guitars is not defined. Oh, and I bet that's because, let's take a look at handle delete. Yes, guitars right there. So here's what we'll do. We'll make this simple enough to where we will delete guitar. We will pass in the ID, and that will take care of that. So of course, this is another function that we will need to export from our data and import here, but that will be easy enough to do. So let's go to our data. Let's export a function called delete guitar, where we get the ID, and then we will simply just paste in that code. So that should work. Let's go back to the browser. Let's refresh here, and voila, it deleted that guitar. If we delete the Starla, that works as well. Of course, let's be sure and check to make sure that adding a guitar works. So let's do the Gibson Flying V once again, and we should see that in our list, and we do. So now we have the ability to display data, to delete data, and to create new data. Well, in the next lesson, you will learn how to serve static files, because Node doesn't do it by default. Even the most dynamic website or application needs to serve static content at some point in time, because CSS, JavaScript, images, all of those things are important to any website. And of course, they need to be served from the web server. Now, I'm going to sound like a broken record, but when it comes to writing a Node application from scratch, we of course have to write the functionality for serving a static file. So what I want to do is serve a CSS file inside of our view function where we have our HTML templates. Right now, we just have a style attribute on the body, and I want to get rid of that because I want to use an external style sheet. Now, the URL itself really doesn't matter, but if I were writing this, it would look like this, to where we would have an assets folder that would have a CSS folder that would then have our CSS file. So that's what we are going to do. Now, of course, if we take a look at this in the browser, we aren't going to see any style being applied. But let's look at the console, because we are attempting to load a CSS file now. And usually if there was a 404, we would see the 404 listed in the console, and we don't. Let's refresh. There's nothing there. Let's take a look at the network tab. We see that the style.css file was requested, and there was a 200 return, so it got a response. But if we take a look at the response, it is our HTML template. And of course, this is because we haven't written any code to handle the URL for our CSS file. So let's go to our index file. And we need to decide, first of all, where we are going to handle this URL. Well, at the top, we are checking if the request method is a post, and you don't handle static content with a post request. It is typically handled with a get request. So we need to do this inside of the else block for our get requests. But then we need to decide, where do we do it here? Now, at first glance, we might want to put it inside of this else, because if the URL includes delete, then we delete. Otherwise, we serve content. However, the main thing here is on line 42, where we write the header for the content type. It is text HTML, and this is not HTML. This is CSS. So what I'm going to do is add an else if, and we are going to check the URL, because we don't need to do any kind of parsing or anything like that. If the URL is equal to assets CSS style.css, then that is our CSS file, and we need to serve it. So now the question is, where do we put our CSS file on the file system? And in most projects these days, you will find the pattern of using a public folder. So the public folder would contain all of the static content that would be served by the application. So we will follow that same pattern, except that inside of public, I want a structure very similar to our URL, so that we have assets followed by CSS and then style.css, although that's not a folder. We need to create those folders first, and then we can create a new file called style.css. So let's go ahead and let's populate this with some CSS. We will have the same thing, so that we set the font size on the body to 2rem, and that should be it. Okay, so now we are checking the URL. If it matches our CSS file, then we want to read that CSS file and write it out to the response. Well, we know how to read a file, and we do so using the read file function from the FS module. But like before, we're going to use the promises API. Now, in this particular case, I don't think we need the access function, because what happens is when we attempt to read the file, if it exists, then great, we will read it, get its content, write it to the response, and we're done. If it doesn't exist, we are going to get an error, in which case we can just return a 404. And I think that that's going to be perfectly fine, even if the error was caused by something other than the file not existing. Returning a 404 is still a good thing, at least as far as security is concerned. So the first thing I want to do is create a variable that is going to store the CSS file name. This is going to be the path, which is the public assets CSS and then style.css. And then we want to attempt to read that file. And we want to await this, which means that we will need to mark this callback function as asynchronous. So let's scroll back down. We will await read file. We will pass in the CSS file name, and we want to specify the encoding, which is UTF-8. And if that is successful, then we will simply just end the response right here, because we don't need to do anything else with this particular response. We just need to end it with that content. However, if an error does occur, then we want to specify that it doesn't exist with a 404. So we will use the status code property on the response. We will set that to 404. And then we will simply end the response because there's really nothing else to do. So with that in place, we should be able to go to the browser. Let's refresh the page here, and we should see our style change. It does. So now we know that not only is the CSS being downloaded, it is being correctly used as CSS and being applied to our page. So that's fantastic. But let's test the case when the file doesn't exist. So we are going to attempt to read a file called style.cs, which is a completely different type of file. But we are going to get a 404. We can see that the CSS was not loaded, and we also see that style CSS resulted in a 404. So that's perfect. That is the behavior that we wanted. And so now we can serve static files. Of course, taking this particular approach, I would hope we wouldn't have many static files. But once again, that's also why when most people write a Node application, especially if it's a web application, they use something like Express, which is what we will get started with in the next lesson. Express is probably the most popular web application framework for Node.js, and for a very good reason. It is very small, but it's also very fast, it's flexible, it's stable, and most importantly, it makes it a lot easier to develop applications for Node.js. Now, at the time of this recording, the version is 4.18.1, and development for Express has slowed down considerably. In fact, let's take a look at the release history. Now, the most recent release we are going to see is the Beta 1 for version 5, which was released in February of 2022. I am recording this in October of 2022. And as we scroll on down, we can see how infrequent the updates for version 5 has been. In fact, if we keep scrolling, we are going to see that Alpha 1 was 2014. So it's been a long time. But if we take a look at version 4, we can see that it gets, well, updated more regularly. But at the same time, I can't really say that this has been actively developed for the past few years, but don't let that scare you away from using Express, because it is incredibly stable. It has been around for a very, very long time, and it is the go-to framework for most developers writing applications for Node. So let's hop on over to the command line. And the first thing we want to do is make a directory for our project. I'm just going to call this node-express. And we, of course, want to cd into that directory so that then we can create a package.json file by using npm init-y. Now, we need that because we are going to install Express. We do so using npm install express --save. We are going to save this as a dependency for our project. This is not a development dependency. This is a dependency for the application to run. And you can see that it is a very fast installation. Express is tiny compared to many other platforms and many other frameworks on those platforms. So with that installed, let's fire up our code editor, and we are going to start with our package.json file because I want to, first of all, say that we are going to use ECMAScript modules instead of CommonJS. So we need to add that type property. The value is module. But then I also want to add a script, kind of like what we did for the previous project as well. Something that gives us a consistent way of starting our application for development. So here we will use Nodemon, and we will just have our starting page or our starting file as index.js. Now, I do want to point your attention to the dependencies property. You know, whenever we talked about Nodemon, we looked at the package.json file and we saw the dev dependencies. Well, now Express is a dependency for this application. So we have this dependencies object. It has a property called Express, and then we see the version 14.8.2. So with that out of the way, let's create our new file called index.js. And the first thing we are going to do is import Express from Express. Now this is a function that we will use to create our application. So the first thing we will do is call Express, and then we can go ahead and we can listen for requests on port 80. So from this sense, it's going to look very much like our HTTP server in that we've created our server. Now we are going to listen for requests, and it makes sense to output something to the console when that application is up and running and listening. So we will say listening at HTTP localhost. So there we go. If we were to run this now, there would be a lot of similarities to what we've done before, but our application wouldn't be very useful because we really aren't handling any requests. So what we will do then is define a route. Well, what do I mean by route? Well, this is a web application, obviously, and we receive requests. So the request has a lot of information about it. There is the type of request. There's also the URL that the request was sent to. So when our application receives the request, it's going to look at that request and look at the different pieces of it, and it's going to route that request to the code that will handle that request. So in this case, we want to define a route for the root of our application, because if we go to localhost right now, let's just do that. Let's fire up our application with npm run dev. Let's hop on over to the browser and let's go to localhost. And we are going to see that it cannot get / the root of our application because we don't have any code handling that request. So we are going to set up a route for that URL so that we will do something for that request. So we're going to use our app object here. This has a method called get. This is the HTTP method. So if we wanted to handle a get request, we use the get method. If we wanted to handle a post request, we use post. If we wanted to handle a delete or a head or a put, those are all methods on our Express object that we've created. So right now we want to handle a get request. The first argument that we pass to this method is the URL that we want to handle. In this case, it's going to be just a / signifying the root of our application. And then we define a callback function. And this function has two parameters. The first is the request. The second is the response. And then we just do something. So in this sense, it's somewhat like the code that we wrote in the previous project with just straight up bare bones Node APIs. Except that this is far more structured. It's also far more flexible because, as you'll see later, we can create dynamic URLs that will give us a lot of flexibility. So here we want to use our response, and we have a method called send. Now, this send method is a lot like the end method that we used for the response in our Node application. So whenever we send data to the response, we are essentially ending that response. So here we are going to say simply, hello Express. And so now, whenever we go back to the browser and refresh the page, we will see that content, Hello Express. So let's take this a step further. Let's say that we want to handle another URL. Let's say that we will have a greet endpoint. So the URL will simply be /greet. Well, in this case, we want to change our content so that we say greetings, Earthling. And now our application has a greet URL. So we can go to /greet in the browser and we see that result. So there's no getting the URL from the request, parsing it out, checking for values. There's no if, else if chains. There's none of that. Our code is highly structured. And as you'll see, as we progress on, it is much more flexible to meet our application's needs. Organization is key for a successful project, and there is no right or wrong way to organize your project, but sometimes it does depend upon the size of your project. If you have a small project, then organization really isn't that important, but as you get into a medium-sized or a large-sized application, yeah, you definitely want some kind of organization. Now, what I typically do is create a folder called app. And then this folder would contain all of the source code for the application. So for example, what we have inside of our index.js file, I would consider application code. This is all code that's necessary for the application to run. So what I would end up doing is inside of the app folder, I'll create a file called simply app.js. I'm going to lift out essentially all of this code. I'm going to put it inside of app.js so that what I end up doing is exporting a function. We could call it start. And what this will do is start our application by calling the listen method. So that inside of index.js, it is very simple. All it does is essentially import that function from the app module. And then from here, all we have to do is call the start function, and there we go. Our application is started. Now, this means that there needs to be some more organization as our application grows here. So let's say that we want to display our guitars, just like what we did before. So what we could end up doing is inside of app, we could create another folder called guitars. And then inside of this folder, we would have all of the files necessary for displaying the guitars. So we could start off with something like a file called index.js. The idea being that this is the main file for our guitars. Let's go ahead and define our data. It is going to be just a simple guitars array. In fact, it is the guitars array that we used in the previous section. But then, of course, we want to set up some routes so that we can display this information. Now, we could do this inside of the app.js file. We could import the guitars, and then we could define our routes here inside of this file. But as I've mentioned before, I like to keep my main file as clean as possible. In fact, I like to keep my files as clean as possible, not just the main file. So what we can end up doing is inside of our index file for our guitars, we can define our routes here, and then we can export them and import them into our app so that it would look something like this. We could import our guitar routes from guitars index.js. And then we could use those routes here inside of our file. So let's do that. In order to define our routes outside of our main application file, we want to import the router class from Express. This is going to give us the ability to define our routes, which we will then export. So let's export this guitar routes, and we will new up the router constructor. Now, before we go any farther, let's talk about the URLs that we want to use here. So in the previous section, we had a /guitars as our URL. Did we do that? I don't remember. So let's say that the root of our application is going to be a /. That's going to be the home page. So instead of displaying Hello Express, let's have home page here as the content. Eventually, we will have some actual HTML that we will output, but for right now, this is going to be fine. So just a /, that's going to be our home page. And then for our guitars, we will have /guitars, which will show the index page for the guitars, which is essentially going to show the list. And then from there, we will have a URL of /guitars/ and then the ID of the guitar, which will show the individual guitar by ID. So that's the idea here. So let's go back to the index file inside of our guitars folder. And we are going to use our guitar routes. And you know what? That's a lot of typing. So let's do this. We are going to create routes and we're going to use routes. That's just a lot easier to type. And then we start defining our routes, just like what we did in the previous lesson by using the app object. This router object also lets us define our routes using the methods of get, post, push, delete, all of those. And in this case, we are going to use the URLs as if they are relative to /guitars. So the index page for our guitars is going to be simply /, but then we also need the function that is going to handle that request. So we have a callback function that receives the request and the response. And for right now, let's just do this. We will send the guitars array. That's going to actually result in a JSON structure, basically. And let's also define a route for the guitar with an ID of 1. Now, ideally, we would not hard code the ID, and we will get to that later on. But for right now, this is going to be fine. This gives us something that we can see in the browser. So that in this case, we will send guitars with the index of 0. So there we go. We have started to define the routes for our guitars. And these URLs are relative to our /guitars. So now we need to go back to app.js. We need to change this up here. Instead of importing guitar routes, we are importing routes as guitar routes. And then we want to use these routes within our application. And we do that with our app object. It has a method called use. And then we pass 2 arguments here. The first is essentially the URL or the base URL that we want these routes to start at. So this is going to be /guitars. And then for the second argument, we pass in the routes that we imported. So this is how it works. Here inside of our app component, all we have to do is say that we want to use these guitar routes starting with the URL of /guitars. And then everything that we defined inside of the guitar routes is relative to this /guitars URL. So with that in place, we should be able to go to the browser. We don't have that greet endpoint anymore, so let's refresh. We see our home page. We want to go to /guitars. We see the JSON structure for our guitars array. Then we want to go to guitars/1, and we see the JSON structure for that individual guitar. Now, of course, we don't have a route for a guitar with the ID of 2 or 3, but we will do that in the next lesson by using route parameters. So far, we have been using static URLs, and there's nothing wrong with static URLs because our applications need them. Like for example, /guitars, that is a static URL. It is hard-coded into our application. Well, not so much hard-coded, but it essentially is. The idea being that it's not going to change. That's what people are going to go to in order to see our list of guitars. Now contrast that with displaying an individual guitar by ID. So we have a route for the guitar with an ID of 1. As it is right now, if we wanted to display the guitars with IDs of 2 and 3, we would have to define routes for those specific IDs, and that's not feasible. So instead, what we can do is use a route parameter. You can think of it as a variable for a URL. we use a route parameter starting with a colon, and then we give it a name. Now, the name needs to be a valid JavaScript identifier. So in this case, ID is fine, guitar ID is fine, guitar underscore, well, I don't know about underscore, because as you'll see here later on, there are some characters that are valid URL characters that are considered part of the URL. We'll take a look at that. So in this particular case, let's just go with ID because that's short and sweet, not much typing there. So now we have this ID route parameter. We just need to get the value that is passed as that segment. And we do that by using our request object. We have a property called params. And then from here, the property names are the route parameter names. So ID. So this route right here is going to match the URL of /guitars/ and then whatever comes after it, as long as it is a single segment. So it can be a numeric value, it can be a string, and those are really the only two options. And that could pose a problem because what if we also wanted to display the guitars based upon their make? So that if we had guitars/Fender, that would make sense as far as a URL is concerned. And we will look at that and how we can solve that particular problem here in a few moments. Let's first of all just work with the ID. So we have the ID, but remember that this value is in the URL, so it is a string. We need to parse it into a numeric value so that we can check it against the IDs in our guitars array. So let's just parse it. We'll use parse int, pass in the ID parameter. We want that as a base 10 number so that then we can try to find the given guitar that has that ID. And hopefully we will find it. If we don't, we'll need to handle that, but we'll talk about that here in a moment. And then let's just pass that guitar on to the send method. So all that should work. So let's hop on over to the browser. Let's refresh the page and nothing should change. That looks good because the Fender Strat is the guitar with an ID of 1. Let's go to Guitars 2. We see that information. Let's go to Guitars 3. We see that information as well. But let's go to Guitars 4. Now we don't see anything, but let's pull up the developer tools and let's go to the network tab. Let's refresh. And we will see that even though we don't have a guitar with the ID of 4, we are still returning a status of 200. And the reason is very simple. We aren't doing anything if the guitar isn't found. So even if this guitar variable is null or undefined or anything, we are still passing that value on to the send method that is being sent to the browser as a 200. So we need to check if we actually have a guitar. And if we don't, well, then we want to send a 404 because the guitar doesn't exist. Otherwise, we want to send the guitar that we have. So now this is going to give us a better experience. So let's go back to the browser. Let's refresh this page and we will see now we have a 404 being returned. We also see not found as the content, but let's go back to the guitar with an ID of 3. Let's refresh. We still see that information. The status is 304, but that's perfectly fine because, well, the data didn't change. So we are good to go there. Fantastic. But what about that case where we might want to also find the guitars of a given make? Well, let's first of all try to define another route, but I'll go ahead and tell you that it's not going to work because the way that routing works is Express is going to look at the incoming URL, then it's going to look at our routes and it's going to try to find a match for that URL. And once it finds a match, it's done looking. It's going to execute that function for that route and that's it. So if we have an identical route as far as the URL is concerned, then it is going to find the first route and it's going to execute that. So here, let's just have send and make method. All right, so if we try this in the browser, if we have an ID, we should still see IDs. Perfectly fine. If we search for Fender, well, we get a not found because the function handling this particular request is for this first route. Now, if we move our make route above the ID route, Well, things are going to be a little bit different. If we refresh this, now we see that we are executing the make route. But if we change that second segment to an ID, we still see that we are executing that make route. So the order in which your routes are important, but also be aware that if you have two routes that essentially have the same pattern, then you're probably going to end up with some behavior that you did not expect. So how do we work this? Because now we have two use cases, one where we want to provide an ID, one where we want to provide the make of the guitar. Well, we just have to modify our function here and take that into account. So what we can do here is check to see if we have an ID. And if so, then we will attempt to get the guitar with that ID, and all that code is still going to work. However, if we don't have an ID, well, then we can assume that the make of the guitar was passed. So we can do something like this, to where we will try to find the guitars that have the given make. And let's normalize these values. So we're going to call to lowercase so that we compare both strings as lowercase. And here we will use the params ID. Now, even if we don't find any guitars with the given make, we still end up with an array. So we need to check the length of found. If it's equal to 0, well, then it's not found because we don't have guitar of that make. So once again, we return or we send the 404. Otherwise, we want to send whatever it is that we found, and that will be an array of guitars. So if we go back to the browser, now we can have our cake and eat it too. If we provide a numeric value, we can see that that is going to be used to find a guitar by ID. If we pass a string, that's going to be used to find the guitars by the make. And let's add another guitar here. Let's add another PRS, and we can make this an ID of 4. The model will be a vela. So let's take a look at that. If we do guitars/PRS, then we get an array of 2 items, the Starla and the Vela. So that works. Now, one of the fantastic things about route parameters is that we can use as many as we need in our URL. So we're going to look at 2 cases here. We are going to add a URL for adding 2 numbers together. So it's going to start with sum, and then we will have a third segment, which is going to be our first numeric value. The third segment will be that other number. And we have our request and our response. And we want to add these together. So we can do that, of course, but we need to parse those into numbers. So we're going to send. Now we're going to use a template string here because if we pass a numeric value, it's going to assume that we are passing a status code. So here we are going to parse int, the a param. We are going to add that to the parse int of the b param, and that should be fine. So here we have 2 route parameters in the same URL. If we go to the browser, let's go to /sum/1 and 2, that should give us the value of 3. It does. If we say 2 plus 2, that should give us a value of 4. So that's all well and good. But remember I talked about the underscore, and that if there is a valid URL character, it is going to be parsed as a valid URL character. So for example, we're going to change our sum URL here so that instead of having 3 segments, we are going to have 2. But what's going to separate A from B is a hyphen. Now that's going to look a little weird because that kind of looks like we are subtracting numbers. But here, let's do 20 dash and then 40. Now in the browser, we should see the value of 60, and we do. And it doesn't matter what we pass as these values. Express is going to parse that segment into those 2 distinct parameters. A is 25, B is 40. So you can get pretty creative when it comes to using routes and route parameters. But with every type of thing that's cool, don't just do something because you can. Do it if it only makes sense to do so. Most modern web applications and frameworks follow a design pattern called MVC, or Model View Controller. Now, model is essentially the data. That's an oversimplification, but within our application, the model would be the data that our application works with. The view is the UI of our application. It is responsible for displaying the data to the user. And then finally, there's the controller. This processes the data, but it also kind of serves as the glue between the model and the view. Now, Express is not an MVC framework. However, it makes it very easy to implement MVC. So what I want to start doing in this lesson is divide our application into these smaller pieces. The reason why you would want to do so is, for one, it makes your code more organized, it makes it easier to maintain and develop, and it also makes it easier to test. And we're going to start by extracting out the functions that handle the guitar's requests. And we're going to put those inside of another file, and this is going to serve as the controller for our guitars endpoints. So let's create a new file inside of the guitars folder. Let's call it simply controller.js. And as I mentioned, I'm going to extract out these functions so that this first function that handles the guitars endpoint, we will export a function. Let's just call it list guitars. And this is, of course, going to work with the request and the response. And it is simply going to send the guitars. Now, we don't have the guitars here, but we can go ahead and we can extract this from our index.js file, and we can put it inside of our controller. Now, the data is the model. Eventually, we will need something that will separate the model from the controller, but we'll get to there. This isn't a sprint. This is a marathon. So small steps will work just fine. So now we want to import list guitars from our controller, and then we will use that function to handle the request for our guitars endpoint, just like that. So as we can see, just by making this change, this file is much cleaner, and it's going to be even cleaner whenever we extract the function for handling the ID or the make route. So let's cut that code out. Let's go to the controller and let's export that function. We could call this show guitar. I'm sure that there's a better name that we could use, but I think that this is going to be fine for our case. And then we'll just paste that code in. Now, since we have our guitars listed here, we don't need to do anything else except import this inside of our index file. So let's do that, show guitar. And then we will use that function to handle that route. So that now that we have cleaned this file up, we can focus on our controller and we can start to clean that up. Even though that this is relatively clean, we don't need our data here. In fact, we don't want it here because we want to separate our application into those pieces of model, view, and controller. So let's create another file inside of our guitars folder. Let's call this model.js. And we are going to put in that guitars array. In fact, we are going to take it completely out. Now, we don't want to provide direct access to this guitars array. Instead, we want to provide some kind of API that the controller will need. So we can have a function called getAll, in which we would return the guitars. But really what we want to do is return a promise that resolves the guitars. The reason being, because whenever we finally switch to a database, the controller needs to be completely ignorant of that change. All the controller cares about is that it has access to this getAll function, and that is going to get us all of the guitars. That's all the controller needs. And so that means that it's up to the model to handle how that data is retrieved. So if we can confine our data access to this model file, then all the better. So for our controller, we will use this getAll method, but it is asynchronous. So we need to mark this as async so that we can retrieve the guitars using await, getAll, and then we will pass those guitars on to the response. The next function that we need would be to retrieve a single guitar by ID. So we can have get by ID, and we would want that ID. So let's go to the controller. Let's copy this code. to where we try to find a given guitar. And then once again, we will use a promise to resolve this because we want all of this to be asynchronous, because eventually when we do get to using a database, all of that will need to be asynchronous. So we will have our guitar. And since we're here, we might as well go ahead and just copy this and use it as a basis for our other function, which would be get by make. And then we would have our make. We'll change this to filter. Our predicate will be make to lowercase, and we would compare that to the provided make to lowercase. And then we would want to pass that result onto the promise. So we can go back to the controller and we can import those methods. So we had get by ID and get by make. So that now if we have an ID, we can await get by ID, pass that in, and everything should still work. We need to mark this as async. But if we don't have an ID and we assume that we have a make, we want to use our get by make function. So before we see if this actually works, let's take a look at the code. We look at our routes, which I guess now we should actually call this routes. So let's do that. We'll name the file routes.js. Visual Studio Code will ask if we want to make the refactoring changes. Yes, I do. And we can see that inside of app.js, it automatically changed that file name. So that's cool. So we define our routes, we import our controllers, we take a look at our controllers, we define them, we import the functions that we need to work with our data. And if we take a look at our model, that's nice and neat as well. So let's go to the browser and let's take a look here. We don't care about the sum anymore. In fact, we should probably get rid of that. But let's go to just guitars. There we see our list of guitars. Let's go to guitar with an ID of 1. That's great. Let's go to an ID of 5, which is not found. That is also great. But we also want to find the guitars that are made by PRS. And our application fails. Of course it does. Nothing can work the first time. So let's take a look here. Cannot access guitars before initialization. And that is my fault because I used guitars here. So let's use found, and that should make that work. So let's go back to the browser. Let's refresh this page. And what do we get? Another error. What is wrong? Okay. Make to lowercase is not a function. Well, then what is it? Let's write it out to the console so that we can see what make is, and then we will go from there. So let's make this request first. Let's refresh. It will fail. So let's go ahead and go to the command line. And what do we have? Not a number. Well, of course, to lowercase isn't a function because we passed the ID, didn't we? We did not pass what came from the request parameters. So yeah, that's an important thing to fix. So now that should work. Let's go to the browser, let's refresh the page, and voila, we have our result. So we now have the model and the controller pretty much sorted out. In the next lesson, we will implement a view. In the previous lesson, I introduced you to MVC, or Model View Controller, and we talked about the model and the controller, but we did not talk about the view. And the view is very important because that is how we display the content to the user. Because as it is right now, we are just sending the data in the response, and it's ending up as a JSON structure, which is perfectly fine if our goal is to write a web API. But in our case, it's not. We want to write a web application. So we can approach views in several different ways. We can use a third-party library or a third-party view engine, which is something that we will look at later on. But for our purposes, I think that it's going to be easy enough to just roll our own for now. So inside of the guitars folder, I want to create a new file, and we'll just call it view.js. And what I want to do is export a function called view. And it's going to be a very simple function to where we accept two things. The first is going to be the name of the view that we want to use, followed by the data that we want to display with that view. And then we will execute some code. But before we get to that, let's talk about how I want to use this. So right here inside of our controller, let's focus on the list guitars function so that we are still going to send content to the response, but we'll do this. We'll use that view function, we'll pass in the name. In this case, we want to display a list of guitars because ultimately when it comes to views, we don't have a single view that's going to fit all of our needs. We will have multiple views for different circumstances. For displaying a list, we will use the list view, and then we will provide the data for that view. To display an individual guitar, we could have a view simply called show, to where we pass in the object that contains our guitar. Now, if you'll notice what I'm doing here for the data, I'm passing in an object that then has a property that contains the data that I want to use. I'm going this route because this gives us more flexibility in the long run, which is something that you will see here later on. But this is the goal that I want to achieve. We just need to implement that. So with that in place, we can go back to the view. And what I want is an object, and we can just call it views. And the methods on this are going to be the names that we specify whenever we call view. So here for our list guitars function, we use the list view. So we will have a list method inside of this views object. This will receive the data that we need to work with. We'll go ahead and destructure it so that we get the pieces that we need. And then we will return some content, and we will get to that here. But now that we have something to execute, let's go ahead and finish this code on line 8, to where we are going to take the provided name and we are going to call that, passing in the data, and that's going to work for us. So now let's talk about the content that we are going to use here. So the list view should be for displaying a list of things, but we don't want to contain the entire HTML document here. Instead, all the list view needs to be responsible for is generating the content necessary for the list. And then for everything else, as far as the rest of the page, we could use what's called a layout. And let's call it underscore layout. Now, the only reason why I am prepending this with an underscore is just so that it sticks out. This isn't necessarily something that we would use by itself. Instead, this is a method that we would use for all of the other views. So you can think of it like this. This is going to provide the layout of our application. So it's going to give us the overall look and feel. And then the individual views are going to be like partial views. They are just going to generate the content that we need for that information. So I'm going to take the markup and paste it in for layout. This is exactly the same HTML document that we were using before. And inside of our list view, we will want to call layout. So we will essentially do this. In our return statement, we will call underscore layout, passing in the content that we are going to generate within this list view. So that's the idea. Now we just need to generate that list. So we can have a UL element for our unordered list, and then we will have LI elements that we will then join together. So now we just need to define that variable called LI elements. We will take the provided guitars and we will call map. So for each guitar, which let's go ahead and destructure this so that we have the ID, the make, and the model, and we will generate an LI element. Now we do need our links here, so we will also have an A element where the href is going to reference the ID. But we need the rest of the URL here, don't we? So we need /guitars/ID. Then we want to display the make followed by the model. We will close the A element and then close the LI element. And let's put this on another line so that that is much easier to read. So there we go. Let's go back to the controller, and there is a syntax error there. So let's get rid of that semicolon. Everything else should work, I think. So let's go to the browser. Let's refresh the page here, and we see our HTML. The links work. If we click on any one of these links, it will take us to, well, the endpoint. We see the JSON structure for each one of those guitars, but that is going to be perfect. So now we can go back to our view, and let's define another view. We'll call it show, to where we will receive the individual guitar. And I don't exactly remember what we did in the previous section, but we'll do this. We will still use our layout, and we will use an H2 element, and we will display the guitar make, followed by the guitar model. And so with that show view, we can go back to our controller. And when we want to display an individual guitar, we will call view, pass in show, and then pass in an object that has our guitar. That should give us the output that we want. So let's take a look in the browser. Let's go back and let's go to any one of these guitar pages, and we should see our expected output. Now, there's one other thing that I want to touch upon. Remember I said that whenever we call the view function and we pass in the data for that view, I want to pass in an object, and then the properties on that object contains the data that we want to display. I said that it gives us a little more flexibility. Well, this is why. So our list guitars function is responsible for displaying a list of guitars. Makes perfect sense. But we also want to display a list of guitars inside of show guitar, because not only do we show an individual guitar, we might also need to perform a search based upon the make, in which case we would get an array of guitars. So if we have any guitars that are found by make, we also can use the list view. It just makes sense to do so because, well, it is working with essentially the same structure. Now, we need to modify this because the view is expecting a property called guitars. So that's fine. We are going to pass guitars with this object, and it's going to be set to found. But let's say that we also want to have just slightly different content between these two controllers. Let's say that we want a title, so that inside of our view, instead of just displaying our unordered list, we could have an H2 element that would have the title for this list. And we could just simply call it title, in which case we would need to destructure that as well. But that also means that we would need to supply the title whenever we call the view function for the list view. So for the list guitars controller function, the title could be something like my guitars. And for the show guitar function, it could be something along the lines of guitars made by, and then we could include the actual make here. So let's do that. Guitars made by. We do need the actual make, which we do have the make thanks to this route parameter, but I want it to be representative of what the actual data has. So in this case, we could use our found object, because if we are here inside of this else, then we have at least one element inside of the found array. So we could get that, use the make property, and that should work. So if we go to the browser, let's refresh our guitars, and there we can see the title of my guitars. Let's go to guitars/PRS. We should see guitars made by PRS, and we see those guitars. But if we want to see those made by Fender, then of course we see Fender. And Gibson, we see the results for Gibson. So don't be afraid of reusing the same view for a different controller function. If the view is working with the same kind of data, it almost makes complete and total sense to reuse a view. And if you need to display slightly different content, you can make adjustments in those cases. Now, if you need to make a whole lot of adjustments and make a whole lot of changes based upon the content, it might make more sense to just create a whole new view. But of course, that's completely and totally up to you and the circumstances. Express exists to make our lives easier as we develop applications for Node. If you will remember from the previous section, whenever we talked about serving static assets, well, that left a lot to be desired. We used static URLs, we used static file names in order to serve a single file. Now, we could have made that more dynamic, but that would have required a lot of extra time. And time is important to us as developers. So if we can do something to save ourselves time, then we ought to do it, which is why we are talking about Express. Because Express gives us just about everything that we need out of the box to build fully functional web applications. So we want to serve static assets because, well, every application needs static assets at some point in time. So we essentially have to do two things. The first thing we do is we tell our application that we want to use static assets. So we call the use method, we pass in express Static, which is a method. And so the second thing we do is tell our application where our static assets reside. And for us, that's going to be the public folder. And that's it. With that single line of code, we have now told our application we want to use static assets. The only other thing that we need to do is create this public folder. Now, this public folder is going to be at the root of our project. It is not going to be inside of app. And if you look at other projects, you're going to see something similar because static assets typically aren't part of the application source code because that is what is inside of the app folder. It's the source code for the app. At the root of our project, we will create a new folder that will be called public. And then anything inside of that public folder is fair game for being served as a static file. So I believe we had the assets folder followed by CSS. And then inside of that CSS folder, we had a file called style.css. And I think that this is already referenced inside of our layout view. Let's take a look. Yes, because whenever I pasted that in, well, I left that there. I copied it from the code from the previous section. So now we have this style.css. We need some actual CSS. And I believe we set the font size to 2 rem. And that's going to give us something visual that we can see to make sure that it works. So let's go to the browser, let's refresh, and voila, our text is now ginormous. Now, the great thing about this is it's going to assume that every URL is for a static asset if it is not handled by one of our routes. So if our application receives a request for a URL that is not handled by a route, it's going to assume that it is a static asset. So it will look inside of the public folder to try to find the file for that URL. If it finds it, great, it uses it, as we saw with the style.css. If not, then, well, it doesn't. So let's take a look at that. Let's go to our view. And let's add a JavaScript file here at the bottom of the body. We aren't going to keep this because this is going to be rather annoying, but what we'll do is add a JavaScript file called hello.js. And inside of this file, it is just going to display an alert box that says hello there. And that would be annoying because we are going to see it on every page. But notice the path here. We are just saying hello.js. So it's not going to be inside of assets or anything like that. It's going to be directly inside of the public folder. So let's add that new file called hello.js to where we alert hello there. And there we go. So if we go to the browser, let's refresh the page and we don't see it. Okay, let's take a look at the developer tools. Let's see, the server responded with status 404. That's fantastic. Tell me what the URL is. There it is. The URL /guitars/hello.js. Oh, yes. Yeah. That's one thing, but this isn't something about Express or anything. This is just how URLs are being handled by the browser. So if we go back to our layout view, the path for this is hello.js. Since we are in the guitars directory, if you will, even though that directory doesn't technically exist, the browser is going to take this hello.js and it's going to assume that it is inside of that guitars. We can get around this by just putting a slash in front of it. And that would tell the browser that this hello.js is directly off of the root. So it would be localhost / hello.js. So now if we refresh this, we should see hello there, and we do. And we will see this on every page because every page is using that layout view. So let's get rid of that because that's going to be annoying. So we will delete that. But that's to demonstrate that if the URL is not handled by a route, it's going to look for that URL inside of our static assets. So we are good to go. As far as static assets are concerned, we can add them to our public folder. We can refer to them inside of our views, and we are going to be good to go. Thank you, Express. You saved us a ton of time. As I've mentioned before, Express makes it so much easier to develop Node applications, and the same goes for handling user input and processing that information. So we want to be able to, of course, provide a form that the user can submit a new guitar, but we also need to process that information. And in order to process the information, we need to be able to essentially parse the body of the request into something that we can use within our application. So the first thing we need to do inside of our app.js file is call app.use, because we want to specify the tool that is going to parse the request body into the format that we need. And we do so using express.url encoded. And we want to pass in an object that has the extended option, and we're going to set that to false. The default is true. So what exactly does this extended option do? Well, if it is set to true, then it uses a library called QS to parse the request body. If it is set to false, it uses a library called queryString. Now, the queryString library is, I don't want to say basic, but it essentially gives us a basic URL encoded string, just a set of key value pairs. So that would be more in line of what we would expect within typical web applications, not just in Node, but just any platform in general. If you set it to true in order to use the QS library, you can end up with a more complex object. I say you can because for very simple forms, especially like for what we are going to do, there's virtually going to be no difference between what we get to work with. However, if we have a more complex form where there's a group of checkboxes or things like that, you can actually end up with an object that has arrays and things like that. So it gives you a richer way of working with the request data. But in most applications, you will typically see this set to false just because, well, for one, that's in line with what we would typically think as far as working with a request. And two, there might be some security implications when using the QS library. So generally, using the queryString library is probably a little safer. So as far as our app file is concerned, that's all that we need to do. Let's open up our view because we need a view to display our form. So I'm going to paste this in because, well, there's markup here. So the view is called form, and this is almost exactly the form that we used in the previous section. The only difference is our action. We are still making a post request because, hello, we are needing to create something, so that is a post request, and the action is for the /guitars URL. Everything else is the same. So with that in place, we can close that, and let's go to our controller because we need a function that will essentially send that view to the response. So let's export async function. Let's just call this create guitar. And we need our request and our response. And we will simply send the result of calling the view function for our form. And that's all that we need to do, at least as far as the create guitar function is concerned. So now we can use that to define our route. So let's open up routes. Let's define routes get. The URL here is going to be create, and then we want to use that create guitar function. So let's go to the browser. And let's go to /create, and we will get a not found. Well, how can this be not found? We just defined that route. Well, it's very simple, actually. Remember that we have a route that already has a segment, and that segment is going to be either a guitar ID or it is going to be the make, and that is being handled by the show guitar function. So if we look at our URL, of course we have two segments here, but let's just think in terms of being relative to guitars. So let's not think about guitars. So we have a URL with a single segment called create. Well, our application will receive that request and it will try to find a matching route. Well, it finds one on line 11 because that URL for that route has a single segment. So therefore, it routes that request to the show guitar function, which, as we know, will attempt to find a guitar with that value. If it doesn't find it, then it will try to find the guitars with the make of that value. and it doesn't find it there either, so it returns 404. That's why we get not found when we try to go to /create. So this is easily fixed. We just need to define our create route above our show guitar route. So as you are defining your routes, you do need to be aware of the order in which you define them, because it does make a difference. In general, you want to define the more specific routes before you define the more generic or the more dynamic routes. There are always going to be exceptions to that generalization, but if you follow that, you will be good to go most of the time. So now we can go back to the browser. Let's refresh and we will see our form. So great, we have that. Now we just need to write the code that is going to handle the post request there. So let's start in our controller, and I'm going to add another function called store guitar. So the terminology that I'm using, create guitar to show the form, and then store guitar to actually store it within our data store. I'm using that terminology from Laravel because I like it. It makes sense. At least it does to me. So we're going to call this store guitar. We need the request and the response, and we want to get the information from the form. So we can do that very easily because the request has a property called body. And then from here, it gives us the form fields as properties. So if we wanted to get to the guitar make, we would simply use guitar_make, or if we wanted the model, it'd be guitar_model. So we can make this a little bit easier to work with by just destructuring that so that we can create a couple of variables, one called guitar_make, the other guitar_model, and we will get that from the request body. Now, the first rule of working with user input is to never trust user inputs. Never assume that you will always get what you expect, because you won't. The vast majority of people are good people. They aren't going to give you problems, but at some point in time, someone will try to find holes within your application, and forms are one of those places that holes can exist. Now, after going through that whole spiel, we are going to be somewhat naive, because ideally, not only are we going to check if there is data here, but we would also want to sanitize this information, meaning we would want to strip out any HTML, any JavaScript, anything like that, so that we just have text. And we will have to talk about that in another lesson. But for right now, this is going to be fine. If we have a make and if we have a model, then we want to store this guitar in our data store. If not, well, then we want to redirect the user back to the form so that they can fill it back out. So we will await, let's say that we will have a function called add guitar. We will pass in the make and the model. And that's really all that we need, because inside of our model file, we will have the code to automatically generate the ID and all of that. So after we save that guitar, or after we store it, then we will simply redirect, I think, back to /guitars. I think that makes sense. Otherwise, what we want to do is send the user back to the form. So we have a couple of options. We could either send the view, or we can just redirect them. And I think redirecting them would be the better option, because if we just send back the form, they can hit F5 to refresh the page, which gives them the opportunity to send the exact same request. And that could be problematic. So we will just simply redirect to guitars/create. Ideally, we would have some other kind of information to go along with that, but for now, this is going to be fine. So now we need to define this add guitar inside of our model file. So let's open that up and let's export function add guitar, where we have the make and we have the model. And the first thing that we want to do is create our guitar object. So we can do that. We will need a function for generating the ID, which we can just call getID. And then we will have the make and the model. And then we will want to add that to our guitars array. So we would call push, pass in guitar, and then I guess we could return a promise here, and then we could provide the newly created guitar. It would be up to the controller to decide if it's going to do something with that. So now we just need the ID. So let's create that ID variable. Let's initialize it as 1. Then we need that get ID function to where we will simply just return ID and we would increment that. And then we would use get ID to create our guitars here. So just like we did in the previous section. And I think that that should work. So let's go back to our controller. I think everything's in place here. So we should be able to see all of this in action. So let's save the file. Let's go to our browser and let's add a Gibson Flying V. So let's save this. We should be redirected to guitars. Cannot post. We went through all that trouble and we forgot to add the route for that request. So here we are going to add a post request for /guitars, and that is going to be to store guitar. Now, of course, we needed to import store guitar as well as create guitar, and Visual Studio Code automatically did that for me. So that's why I did not add that, because I'm relying upon my developer tools to do that. So let's resubmit this. We'll continue and we get an error. So let's take a look at the command line. We see that add guitar is not defined. And of course it's not, because we did not import that inside of our controller. So let's do that. We want add guitar. Once again, let's go back to the browser. Let's refresh the page. We will resubmit that request. And now we can see that it worked and we have our Gibson Flying V. Of course, if we click on the link, it will take us to the individual page for that guitar. And now that we can create a guitar, we need to be able to edit a guitar, which we will look at in the next lesson. There are a lot of similarities between editing and creating, primarily because you work with the same kind of data or the same structured data. There's just a few variances here and there. So this means that we can reuse some of the code that we wrote in the previous lesson whenever we implemented the functionality for creating a guitar. But of course, there's some things that we can't. So it's just a mixed bag. So let's start with our route. And as far as the URL is concerned, we will start with the ID of the guitar, and then we will have edit as the next segment. And this is a GET request, so this is for displaying the form. Let's call this function edit guitar. And then we first of all want to import this so that I don't forget to do that later, because I probably will. And let's go to the controller and we will export that function. I'm going to grab the create guitar and use that as a basis. Now, we can't just essentially do the same thing, because we need to validate the ID first of all, and then we also need to try to get the guitar with that ID. So let's start by parsing out the ID from our request parameters. And if we don't have an ID, then of course we want to return a 404. So we will check if we don't have an ID, we will send 404, and then we will return. Now, this particular pattern is a little different than what we've been doing thus far. We've been using an if-else. If we don't have something, then we will send a 404, else we will do something else. And that's all well and fine. That is certainly clear, but from a personal standpoint, I hate nesting. So if I can avoid nesting inside of nesting inside of nesting, then I do that. So that is why I'm using this pattern here, which is different than what we did before. So if we don't have an ID, we return a 404, and then we return. Now, the reason why we return is because we want to exit this function. Because if we don't exit the function, even though we have sent a response of 404, the rest of this function is going to execute, which is, first of all, inefficient. And if we don't have a valid ID, then that's going to cause some other errors. And there's no reason to do that. So we will simply return out, and then we'll be good to go. Now, if we've gotten this far, then we have a valid ID. So we want to try to get a guitar with that ID. But it is entirely possible that one does not exist. So we need to check if we don't have a guitar, and we will once again send a 404 if that is the case, and then we will return. Now, we could have done it like this, to where we parsed out the ID, then we tried to get a guitar with that ID so that we could have one if statement, so that if we don't have an ID or if we don't have a guitar, then return a 404. From a code standpoint, that is more concise. But from a processing standpoint, that's not very efficient, because if we don't have a valid ID, then there's no reason why we should be trying to get a guitar with an invalid ID. So from a code standpoint, it looks a little redundant, but it is more efficient from a processing standpoint. So if we've gotten through all of these checks, we finally have a guitar and we want to display the form. Now, we could create a new form just for editing, but we don't have to. We are working with the same kind of data. Really, the only difference is that, well, first of all, we have data to work with, but second, we also have an ID. So let's pass this guitar to our form view, and then we will modify our form view to take that into account. So let's go to that view, and we are going to accept the guitar. And what I essentially want to do is have a value attribute for our two fields, and I want to set this to a make and a model. So let's go ahead and let's write that code out, and then we will actually make this work. We also can make the action dynamic too, based upon if we have a guitar or not. So we could also essentially do the same thing to where we have a variable called action, which will contain the appropriate action for whatever it is that we want to do. So now we just need to make all of that work. Now I'm going to start by defining action as simply /guitars. That is for creating a guitar. And let's also initialize make and model. Both of those will be empty strings. However, if we have a guitar, then we want to change the values of these variables. So we will check if we have guitar, and if so, then we will set action to /guitars/guitar ID. So that is where we are going to send the post request to, because that kind of makes sense. Ideally, we would use an update request, but when it comes to HTML forms, the browser can only send get and post requests. It can send an update request through JavaScript, but not through just traditional form submission. So we're going to have to handle a post request for guitars / and then the guitar ID. So we have set the action. Let's also set the make. That is going to be the guitar make. And then finally the model, which will be guitar model. And that's essentially it. So we can reuse our same view. We just need to make a few modifications to handle whether if we are creating a new guitar or if we are editing an existing guitar. So everything else should be fine. So I think we can actually close the view file and we'll be done. All right, so I think we have everything in place for at least displaying the edit form. So let's go to guitars1, edit, and sure enough, we see our form. We see the data already populated. Let's do a sanity check though. Let's make sure that create is going to work okay. We'll have the Gibson Flying V. We'll save that and we should see, well, there it is right there. So if we go to /edit, then we see the edit form. Great. Now that's not going to work because as we make changes, it's going to restart our application and we will lose that entry, but that's okay. Well, now we need to set up the post request. So the URL is going to be just simply /ID. This of course needs to call the post method. And then the controller function will be update guitar. So let's go to our controller. Let's take the code from our store method and we will use that as a basis. Now, when it comes to actually processing the form and saving data, it's almost a combination of what we did to retrieve the guitar and then what we did to store the guitar. There are, of course, going to be some differences there. So we can leave this code for now. But what we need to do is essentially validate the ID. We also need to make sure that we have that guitar and then respond accordingly there. So let's grab those first few lines from the edit guitar function. Let's paste them into the update guitar so that if we have valid information to work with, well, then finally we will update our guitar's information. So Down here with guitar make and guitar model, we will simply set the guitar make equal to that guitar underscore make variable. We will do the same thing for the model of the guitar. Now, since we are working with all in-memory data, this would actually be sufficient, but I don't want to do that. I want to actually have a function that we will call. We can pass in the guitar that we want to save. But as far as our implementation inside of the model, we don't need to do anything since really the updating is being done right here. If we were working with a real data store, then yes, we would definitely need to call a function. So let's go and define that function. This should be pretty straightforward. In fact, let's just take what we have for add guitar and let's change the name for save guitar. We don't need really anything inside of here except the return of the promise. And what we could do is just return true here. I mean, that's not typically something that we would use. We might find that useful at some point in time to check to see if the guitar was actually updated or not, but this is going to be fine. Now, as far as what we redirect to, whenever we are saving the guitar, we would want to redirect back to that same guitar, I would think. So let's change this redirect URL so that we will go to /guitars/ and then the ID. And we will do the same thing for this else statement, except that instead of going to the create URL, we want to go to the edit URL. So we will change that there. And so let's go back to the browser. And let's create a guitar because we've lost that flying V. And once again, we will put in Gibson flying V. We will save it. That should save. Everything as far as creating should work, but of course it wouldn't. Something had to fail. So let's take a look. Update guitar is not defined. That's because we did not import that. So we need to go to routes and we need to import update guitar. Inside of controller, we probably need to import that save guitar. It's always the small little details that I forget to do. So with that in place, we should be able to go back to the browser. Did we submit? Yes, we submitted. Okay, so we have our Gibson Flying V. Oh, no, it's not a Flying V. I meant an Explorer. So let's edit that. We will change it to Explorer. And whenever we save it, it should take us back to our guitar, and it does, and it edited it. And so if we take a look at our list, we will have our list of guitars, but now we have Gibson Explorer instead of the Flying V. Our application has the ability to list, create, and edit data. Now we just need to delete data. And we will start with our routes. Now, as far as the URL is concerned, we will follow the same pattern to where the first segment will be the ID, and then the second segment will be whatever action that we want to perform. In this case, it is going to be simply delete. And the controller function, we will call delete guitar as well. Let's go ahead and import this so that I don't forget to do that later on. And then inside of our controller, we will just define that function. Now, we have a couple of options as far as how we want to approach this. Because, yes, we will still need to validate the ID. If we don't have a valid ID, then there is nothing that we can do, really. So let's start there. But then the question is, okay, do we validate if we have a guitar, or do we just pass the ID on to the model and then let the model figure it out? I guess the quote-unquote correct thing to do would be to try to get the guitar with that ID so that we could return a 404 if that guitar didn't exist. But I don't know. It could go either way. So I'll let you make up your mind how you want to approach that. I guess I'm going to leave the code for checking if we have an actual guitar. And if we do, then we will want to remove that guitar from our model. Now, what do we pass? Do we pass in the guitar or do we pass in the ID? Because ultimately what we will need is the index of that guitar in order to easily remove that. So I guess let's pass in the guitar. And then from there, we will just simply redirect back to the guitars list. So we will remove the guitar, we will redirect back to /guitars, and that'll work. So let's import this function. and then let's define it inside of our model. So this is going to receive the guitar that we want to remove. That should make it easier so that we can get the index from guitars. We want the index of the provided guitar, and then we will splice it out and remove that one item. So there we go. That should be fine. I guess we should return promise. And let's do what we did with save guitar and just resolve as true. I mean, ideally we would resolve as true or false, but this is going to be fine. I'm going to be lazy. So let's go back to the browser and let's go to one of these guitars. Let's go to the Les Paul and let's go to /delete. And that deleted that guitar. Wow, our code worked the first time. Isn't that something? So if we try to delete all of the other guitars, of course, those are going to work, and fantastic. So that if we remove all of the guitars, then, well, it helps if you type delete correctly, then of course, those are gone. But now we can create a guitar. Let's have a Fender Telecaster. Let's save it. Oh, no, I didn't mean a Telecaster. I meant a Jaguar. So let's change that to Jaguar. We will save that edit. And of course it's there, but no, we're going to sell it and it's gone. And that's fantastic. However, as it currently stands, anyone can create, edit, or delete guitars. And we don't want that. We want some kind of authentication in place so that only authorized users can do that. So we will start adding user authentication in the next lesson. Before we implement our user authentication, we need to talk about middleware. Now, middleware is not unique to Express or even Node. This is a concept that is used in every modern web application framework, regardless of what platform that framework runs on. And middleware is aptly named. It is software that sits and executes in the middle of the process of handling a request and returning a response. And it probably won't surprise you to learn that we have been using middleware pretty much since we started using Express. Just about every time we call use, we are setting up middleware. So our static file handler, the URL encoded body parser, even our guitar routes, all of those things are middleware. And we can write our own middleware. It can be as easy as writing a simple function, or we can make it as complex as we need. And in this lesson, we are going to write some middleware to log requests. And we are going to apply this at 3 different levels within our application. We will start at the application level, then we will move it to the router level, and then we will apply it to individual routes. So first, the application level. I'm going to define this log request function inside of app.js. And the parameters are going to start very similarly to the functions that we use to handle requests. We will have the request and then the response, but then we will have a third called next. And next is essentially a function that we will execute to tell our application that we want the next middleware to process the request. And the vast majority of time, we will want to call next. There will be some times that we don't, and if we don't, we run the risk of essentially hanging up our application because, well, it won't finish processing the request. But there are some legitimate times you don't want to call next. Now, for our purposes, we just want to write the request URL to the console. So there we go. And now we just need to tell our application that we have this middleware that we want to use. So we will call the use method. We will pass in the log request function. And there we go. We have now set up our application to use our own middleware. So let's go to our browser and let's make some requests. So let's start at the root. Then let's go to the sum URL. We have one already in our history, so we'll use that. Then we can go to some of our guitar URLs. So let's go to guitars. Let's go to the Velo, which has an ID of 4. Then let's go to edit. I think that's enough. Let's go to the console and we see some entries into our log. We have a slash, that is the root, followed by the sum URL. Then we went to guitars. Then we went to guitars/4. Then we went to guitars/4/edit. So great. We've written our own middleware that is logging our request. Hooray. Well, let's do this. Let's lift this out. of our app. And then let's apply this at the router level. But we do need to make a modification here, because whenever we visit any one of these URLs, the URL that will be listed in the console will be relative to /guitars. So it could be a little confusing. So let's do this. We'll have /guitars, and then we will concatenate that with the URL. And just like with our application object, we want to use our routes. We'll call its use method, and we will use the log request function as middleware. So there we go. Let's make some requests once again. Let's start at the root, at just localhost. Let's go to the sum URL again, but let's use some different numbers here. Let's have 200 and 300. That'll give us the result of 500. Then let's go to some guitars URLs. So we will go to /guitars. Then let's go to the Fender Strat. Then let's go to delete, and that guitar will be gone. Okay, so that's enough. Let's go to the console, and remember the order that we went. We went to the root of our application, followed by sum, and then we started with guitars. So notice here that we start with guitars, then we went to the guitars /1, then we deleted it, and that automatically redirected us to guitars. So all of the URLs that are not handled with the guitars router are not listed here, therefore meaning that this middleware was only applied at the router level. Well, that's great. Well, let's say that now we want to use our log request middleware, but only on individual routes, and really only on those routes that have an ID. And we can easily do that by passing the log request function as the second argument to our get or post methods. So the first argument will be the URL, the second argument will be our middleware, and then the third argument will be the controller function. And we just need to make that same change to every URL that has an ID. But now let's do this. Let's modify our log request so that not only do we include the URL, but we will include the HTTP request type as well. So we will use the method property. Let's have a tab, and then we will have our URL with guitars, and then we will include the request URL. So let's save that. Let's go back to the browser. Let's go to /guitars. Let's go to guitars create, and let's create a new guitar. So that will be a Gibson Flying V. We will save this. Now let's go to the Gibson Flying V. Oh, we made a mistake. That is supposed to be an Explorer. So let's edit. Let's change it to Explorer. We will save it. And then let's delete it. That will take us back to our list so that now we can go to the console and we can see what we get. We made a get request for guitars /5. Now remember, before that we went to /guitars, then we went to create. So notice that that's not listed here, but now we can see where we went to the guitars with an ID of 5. We edited it, which resulted with a post request. We made another get request to display the guitar. That was, of course, after the redirect from our post, and then we deleted the guitars, which redirected us back to the guitar list, which is not listed here. So we have a lot of flexibility when it comes to where and how we want to use our middleware. So now let's shift this to the discussion of user authentication. Well, we want just anyone to be able to list our guitars. And the same is true for displaying an individual guitar. But for anything that involves changing our data, we want to protect. So in our case, it would make sense to apply our authentication middleware at the route level. So let's change this function name. We will call it checkAuth. And of course, we need to change where we have used that function, but we also need to apply it to every post request and every get request that involves displaying a form. So that would be create, that would be edit, that would be delete, and that would be for the post to the guitar ID. I think everything else should be good, although we need to remove the middleware from the get request for displaying an individual ID. The next thing we need to do is modify the code within this checkAuth function. We don't really care about logging anymore, but we do care about protecting it. So let's do this. Let's start with a variable called isAuthenticated, and we will start by setting that to true. We will check the value of is authenticated, and if that works, then we will call next. Otherwise, we want to essentially redirect the user to a login screen. Now, we don't have that yet, but we can still at least redirect the user. So we will redirect the user to /login, and that will be it. Now, this is a case to where we don't want to call next because we don't want our application to continue to process that request. So let's go to the browser. Let's check to make sure that this is going to work. So we will go to one of the guitars. Let's go to edit. And of course, yes, that's going to work because right now we are simulating that we are authenticated. But let's change that value to false. Let's go back to the browser. Let's refresh this and it should redirect us to login, which it does. And so now we need a login screen, which we will implement in the next lesson. We need to provide the ability for users to authenticate so that they can be authorized to make changes to our guitars. And I want to put all of this authentication stuff inside of its own folder, just so that it is nice and contained and kept together, but also kept separate from everything else. So I'm going to call this folder simply auth. This is, of course, inside of our app folder. And then I'll create a few files. The first is going to be the controller. We will also need a file for the view, and then we will need one for the routes. I don't think that we will need anything as far as a model is concerned. If we do, we can add that at a later time. But for now, I think that this is going to be fine. Let's start with our router. So we, of course, want to import the router from Express. And then we want to create our routes. And we want to export this because we will need to use it inside of our app file. So let's just call it routes and we will new up the router constructor. Now, as far as the routes are concerned, we essentially just need two, at least for right now. They are both going to be for the root of these routes, which is going to be /login, but we will set that up whenever we add the routes to the application. And the GET request is going to show the login form. Then we will have a POST request, which is going to handle the form data and attempt to authenticate the user. So let's just call that function authenticate. So let's go ahead and write the import for those things. They, of course, don't exist, but they will here in a few moments. And if I don't do this now, I'll forget to later. So let's go into our controller. And we are going to need access to our view. So let's go ahead and import our view from view.js. And we'll start with the show login function because that will be the easier of the two. And we will have the request and response. And we will simply send our view and we can call that login form. And that will be it. Now for the authenticate function, we will need to pull information from the request body. And let's say that we will have two fields, one for the email address and one for the password. So those are the values that we want to work with from the request body. Let's check to see if we don't have an email or if we don't have a password, because if we don't, well, there's nothing to process there. And we will simply just redirect the user back to the login screen. But if we do have those values, then we, of course, want to compare them with valid credentials. Now, we don't have a way of storing user data right now, so we're just going to hard code this in. But let's say that if the email address is admin@admin.com and if the password is equal to password all lowercase, then the user is authenticated. So eventually we will need to do something to denote that the user is authenticated and that they have access to, well, the protected things. And then we will redirect the user to the guitars, because at this point in time, if they are signing in, there's only one thing that they are going to do, and that is going to manipulate our guitar data. Now, if the credentials are not valid, then we will redirect the user back to the login form. And so now we just need to go to our views file and we need to create that view object. Let's start by copying what we have inside of our guitars views. And let's just paste that in because really the only things that we need is the layout, which is going to be the exact same thing. And the form is, well, it's going to have the same structure. So let's change the name of this to login form. We don't need the guitar. We don't need to do anything before we return our form here. But we do need to make some changes here. The action is just going to go to /login. We don't need values for our fields, so we can get rid of those. The name of these fields are going to be email. Let's change the text for that. And then for the model, that will be password. The type of this field will be password. And then the name of the guitar will be password as well. And then finally, the text of the button, let's just say sign in. And that should give us everything that we need so that inside of our app file, we can import those routes. So let's copy the guitar routes statement. And we want to call these auth routes from auth/routes. And then we will use that just like we did with the guitars. But the URL is going to be /login. And of course, we will use the auth routes there. So that should work. Let's go to the browser, let's refresh here, and we should see the form, but we don't. There's an error somewhere. So let's take a look at the console, cannot find module, routes.js inside of auth. Well, let me make sure that I put that inside of the correct folder. I called it router, not routes. So let's rename that to simply routes. So that should work, or at least that should make our application work. Let's refresh. We see our form. So let's test this out. So if we don't submit anything, then we are redirected back to login. That was perfect. Let's type something that is not valid, and we are redirected. That is perfect. Let's type in a valid email address. That was admin@admin.com, but the password is not going to be valid. And so now let's test admin@admin.com with password as the password. That should take us to guitars. But then the question becomes, how do we track a user after they have authenticated? How do we know that a user has been authenticated? Because by default, the web is stateless. Our application is stateless. Currently, our application has no idea that we are the same user. I mean, yes, we can get some information about the request itself, like the IP address of the client that made that request, but that's not really going to help us keeping track of authenticated users. But we can do all of that with sessions, which we will look at in the next lesson. HTTP is a stateless protocol. That means that when you make a request to a web server, it will of course respond to that request, but it will completely forget you after the response. So if you make another request, well, you're just another client. It doesn't remember you, so it will respond, and that's it. Now, web applications, on the other hand, well, they do track you. And that's not a bad thing, because if we can't track our users, then web applications are useless. Like, for example, we provide the user the ability to sign in. And if they provide the correct email and password, then great. But what do we do after that? We can't track the user in between individual requests. Well, that's where something called sessions come into play. Now, sessions are not built into Express. We have to install the Express session middleware. But we, of course, want to save this as a dependency, and after it is installed, all we have to do is tell our application to use this middleware, and then we can use sessions within our application. So inside of app.js, we want to import session from Express session. And then we just need to set that up. And we want to do this before we start defining our routes, because the session middleware will not work for us in that case. All right, so whenever we set up our session middleware, we need to supply 3 options. The first is called secret. This is an arbitrary text value that is used to sign the cookies, because sessions involve 2 pieces. The first are the cookies that are saved on the client. The second is the session data that is stored within the application. And the cookie on the client corresponds with the session data in the application. That's how our application knows to use session data for a particular client. So this secret value needs to be kept safe. It also needs to be something that is not very guessable. Because if an attacker got this information, then they would be able to forge cookies for our application, and we definitely don't want that. The second option is called save uninitialized. Now, this is a Boolean value, and if it's set to true, then it will save sessions that are not initialized. Now, for our application, we are only going to set up a session for users who are authenticated. So it makes sense for us to set this to false because we don't need to store sessions for unauthenticated users. Now, if we needed to track certain information about all users, then yes, we would want to set that to true. But for our case, no, we'll set that to false. Then the third option is called resave. Once again, this is a Boolean value. If it's set to true, then it is going to resave the session data, even if that data didn't change. Once again, I don't see any reason for that, so we're going to set that to false. And there we go. After setting up the session middleware, we can now use this session within our application. And we will do so inside of the auth controller in the authenticate function, where the username and the password are correct. So this to-do statement, we can finally make this work. And we access our session using the request object. And then we just add values to our session. Now we can use individual values, like if we wanted an is authenticated property, then we could do that. Or we can store more complex information, like we could have a user object to where we can keep track of the user email. That way we could be a little more personal with our users. And we could also, for redundancy, add an is authenticated property here. Now, I say that this is redundant because if we have a user object, then the user is authenticated. However, this is just a personal preference of mine. I like to have a flag that indicates if a user is authenticated. So this is for my own personal preference. You can do whatever you want to signify that a user is authenticated. So with that in place, we are storing information within our session for a given user. And so now inside of our check auth function, inside of our guitar routes, we have this is authenticated variable. So we can access our session once again, and we'll check if we have a user, but let's also check if we have that is authenticated value as well. If both of those are true, then of course the user is authenticated, otherwise they are not. So we are good to go here. Let's go to the browser, let's sign in, and then we will want to try to edit or delete something. Let's try to delete this guitar. So if we do delete, and that worked. So we are authenticated and our application works now. We have protected those endpoints. But now I'm thinking for the future. We have the ability to check if a user is authenticated. What if in the future we develop other features for our application that we also need to check if a user is authenticated? So it kind of makes sense to break this out, and I'm not really sure if the best place to put that is inside of the auth controller, but I think that's where I'm going to put it. So that we can still have access to it, we will export it, but that means we will need to import it everywhere that we need to check if a user is authenticated. And that's going to work just fine. Now, there's another thing that we need to do, and that is provide the user the ability to sign out. That is a security concern. So let's go to our auth routes, and let's set up a route. It's going to be a GET request. It's going to go to log out. I don't necessarily like where this is going because whenever we set up these routes for our application, we did so using the /login prefix. And with a logout, that would mean our URL is /login/logout, and I don't like that whatsoever. So what we'll do is inside of app, we will get rid of just /login and we will make that simply /. And then inside of our auth routes, we will use login for the login and logout for the logout. We need the logout function from our controller. So let's go ahead and import that so that in our controller we can define that. So we need to export function logout. We need the request and the response. And this is going to be very simple because when it comes to essentially logging out a user, what we want to do is destroy the session. So we will call the destroy method on the session object, and then we can redirect the user, I guess, back to the root of our application. So let's give that a try. Now, because we've made changes and our application is restarted, we are signed out. So let's sign back in. We will go to the login page where we will log in. And just to make sure, let's try to do something that requires authentication. So let's once again delete a guitar. That is deleted. So now let's log out. So we will go to /logout. We are redirected back to the home page, but now let's try to edit or delete something. So let's go to guitars/to/delete, and we are taken to the login form. So we are successfully authenticating the user. We are checking if they are authenticated thanks to our check auth middleware. And we have also provided them the ability to sign out of the application. Our little view engine works. And as I've said before, there is something to say about code that works. However, ours leaves a lot to be desired. And one of the things that I really hate about it is that all of our markup is inside of JavaScript strings. Now, template strings make that a lot easier to work with, but still, I really detest this approach. So I want to move into using a real view engine within our application. But unfortunately, when it comes to view engines for Express, there's not really a lot of good options. In fact, most of them are just horrible. Now, one very good option is based upon React. If you have any experience with React, and if you like React, then that is an option for you. Another option is Express Handlebars. Now, if you're not familiar with Handlebars, this was a templating engine that was popular before we had UI frameworks like React and Vue. This was created so that we could generate HTML and inject that into our documents. And then later on, it was adapted as a view engine for Express. It's simple to use, but it's also very flexible because you can define your own helpers, your own functions, your own template directives if you ever need to do that. So we are going to switch our application to start using Express Handlebars. So we need to start at the command line because we need to install Express Handlebars. And of course, we want to save this as a dependency. And then we need to tell our application that we have this view engine. So we will go to the app.js file. And the first thing we need to do is import the create function. Now, create is rather generic, so I'm going to alias this as create handlebars. And then we need to create our handlebars object. I'm just going to call it HBS, and we will call the create handlebars function. Now, if we needed to supply any options, we would do that here by passing an object to the create handlebars function, and then the properties would be those options. But we don't need to. We do, however, need to tell our application that we have a view engine. And we start that process by calling the engine method, and then we give it a name, handlebars, and then we pass in the engine itself, which we get from our handlebars object. It is called simply engine. And then we need to set a setting within our application called view engine. And this is basically just the extension of the files that Express needs to expect for our views. And the default is handlebars. So we are going to have files that have an extension of handlebars. That's a long extension, but that's just typically what we do. And then we want to set another value called views. This is the location that our views are going to exist within the file system. And I'm going to create a new folder inside of app called views. So we are going to define all of our views there. So let's go ahead and let's do that. Let's be sure that we are inside of the app folder, and we will actually create two folders. The first will of course be views, but then we will have a subfolder called layouts, because Handlebars supports layouts. And really by default, it's going to expect all of our views to use a layout. So let's go ahead and create a layout called main.handlebars. Now let's go to one of our view files for either the guitars or the auth. Let's see, this one is for the auth. And let's just take the markup that we have here for our layout. Let's copy that. Let's paste that inside of our main.handlebars file. Now, there's a couple of things that I want to do here, but first and foremost, we need to change where our content is going to go, because the way that Handlebars works is very similar to our own view engine, whereas we have a layout, and then we also have these partial views. And the partial views are going to be rendered inside of the content of the layout page. So we need to essentially tell Handlebars where that content is going to go. And we do so by using 3 sets of curly braces. And then inside of those curly braces, we use simply body. And that's it. Now we can do other things inside of this layout, which we will add a title and things like that later. But for right now, let's go back to our auth views. And I want to copy the login form. So let's just do that. And then inside of the views folder, we are going to create another folder called auth, because we could just throw all of our views inside of the views folder, but I want some structure here. I don't want all of our views just thrown into the same folder, because then we run into issues with naming and things just get very cluttered. So we will have a subfolder called auth, and then inside of that folder, we will have a file, which we can just call login form, or we can just do login for short, but the extension needs to be handlebars as well. And then we will paste in the markup for that view. So the idea now is we have extracted the views that we used inside of the auth controller, and we are going to use handlebars now to render these views. So let's go to our auth controller, and we don't use the views inside of authenticate. We don't use it inside of check auth, but we do so inside of show login, where we send the view to the response. Well, now we don't do that. Handlebars has a method called render, and then we specify the name of the view that we want to render. Now, because our login handlebar is inside of the auth folder, we need to start with auth / and then login. Now, we could add the handlebars extension, but Express is supposed to know to automatically add the handlebars extension. That is why we set up the view engine setting inside of app.js. So if we go to our application and we go to /login, we should see our login form. And just to prove that this is coming from our handlebars, let's go to the login view. Let's change email to simply email address. And whenever we view this and refresh the page, voila, we see email address. So now that our login controller is using the handlebars view engine, we can get rid of the reference to our view.js file, and we can even delete that file from the auth folder. So let's go ahead and do that. Let's clean things up. And there's one other thing that I want to do. If we go back to the browser, we have guitars here as the title of the document, and that's okay, but it's not so for this particular page because this is to log in. And if we take a look at our main layout, we see that, of course, guitars is set as the title. So what I want to do is delete that, and I want to be able to provide a title at any time. So we will essentially create a variable that we will reference here. And we do so by using 2 sets of curly braces, not 3 like we did for the body. We are using 2 sets of curly braces, and then we define some kind of variable that we want to use. So now let's go back to our controller. And yes, we still want to render the auth login view, but now we also want to supply model data for our view to display. We now have a title property, even though that it is inside of our layout page, we will still be able to supply the title here, and we will call the title login. So now whenever we save this, let's go back to the browser and refresh. We can see that the title changes, and that's exactly what we want. So now in the next lesson, we need to start adjusting the rest of our application to use handlebars. Now that our application is set up to use handlebars as its view engine, we need to start migrating our guitars to use handlebars. And we will begin with the main page, the list of those guitars. So let's first of all create a new folder and file inside of the views folder. The folder name will be guitars, and then the file name will be list.handlebars. And we can take this H2 element and then the UL element and just lift those out into that list.handlebars file. Now, of course, we do need to make some changes here. Like, for example, the title uses a different syntax. We use a pair of curly braces, and then we simply have the title variable inside of that. Now, for the LI elements, things are going to be very different because before, since we had a mixture of JavaScript and markup, we were able to essentially generate whatever markup we needed inside of JavaScript, but that's not going to be the case now. But that's okay because Handlebars has all of the tools that we need to generate whatever markup that we need. So we want to iterate over the guitars array. And so we do so with the each directive. You can think of this kind of like a for each loop. And so for each thing inside of guitars, we are going to generate some LI elements. And then when we are done with that loop, we need to close it out with a slash and then each. Now, the way that this works is inside of this each loop, we can reference this. And this is going to refer to the guitar that we are working with at this particular point in time. So if we wanted to output the make and the model, then we would have this.make and then this.model. And all we have to do now is go back to our controller to where we display that list that was inside of the list guitars function. And instead of sending the response and calling our own view, we are going to use the response's render method. We want to render the guitars/list view, and then we need to supply essentially the same information that we supplied our view. So we need the guitars. We also need the title. And so with that in place, we should be able to go to the browser and go to /guitars, and we will still see our guitar list. Now, we've lost the links here, but that's easy enough to do. We can go back to our list view, and let's add an A element that wraps around the text. And really, the only difference here is that for the href value, we use our templating syntax. We have the double curly braces followed by the ID of this guitar, and then we close out the A element. So once again, if we go back to the browser and take a look at this change, our links are there. We can click on these links, and they of course take us to the individual pages to show that guitar. Now, we used that same view for displaying the guitars by a given make. So we can essentially take that same code and use that inside of the show guitar function. So instead of sending the response, we call render. We do need to set guitars as found. And we had some dynamic text, didn't we? Let's not just replace that. Let's paste it in and then make the necessary changes. So our title is going to be dynamic based upon the make. But that's it. That's all we have to do. We have the same view. We can reuse it. So we can go to the browser and we can test that out by going to guitars/PRS, and we see the guitars made by PRS. Well, since we are working inside of the show guitar function, let's go ahead and implement the show view. So once again, inside of the guitars folder, inside of our views, let's create a new file, which we will just call show.handlebars. And I believe this one was very simple. Let's go to our view and let's find that show. There it is. We just had an H2 element and we output the guitar make and model. But all we need to do is change the syntax so that we have double curly braces around each one of these values. Now, we can also pass a title because I don't think that we did that originally. So let's take a look here. Whenever we call send, yes, we passed in the guitar, but no title. So let's add a title, and it can be redundant considering the content of this particular page. So we could do something like guitar and then we can include the guitar make and the guitar model. But of course, we need to change this. We aren't calling view anymore. We are calling render. So let's make that change. The view name is guitars/show. Clean up the syntax errors, and that should be good. So if we go to the individual guitar page now, we should see our same content as we did before, but notice that the title is now guitar and then the name of that guitar. So just to keep things straight, let's go to our old view. Let's delete the show and the list views so that we know that those have been implemented, so that now we just need to implement our form. Now, this one is going to be a little more involved because we actually output different content based upon the values, and we will look how to do that in the next lesson. The view for creating and editing a guitar is very different than our other views, primarily because it changes the output based upon the data that it receives. Now, it makes it sound like that it drastically changes the output, but it basically provides a different value for the action, as well as the make and the model for those form fields. It's not that big of a deal. However, in MVC, views are typically dumb, meaning that they don't do any kind of processing. If they do, it is very simple, making a decision, or it is iterating over a list of things to generate output. One approach that we could take is to provide the action, the make, and the model from the controller itself, and might actually be preferable. But instead, we are going to make decisions inside of our view so that you can see what that feature is like. We are going to go to the Views Guitars folder. Let's create a new file. Let's call this form.handlebars. And let's take our form markup from our existing view. Let's copy and paste that into our handlebars. Now, of course, there are some things that we need to change here. Instead of using the template string syntax, we need to change that to double curly braces, rounding things like the action, the make, and the model. And we need to decide how we are actually going to make a decision here. Well, handlebars has us covered. Just as there was the each directive, we also have a directive for making a decision with the if statement. It's very much like a traditional JavaScript if statement. We say if, and then we provide condition. So in this case, our condition is if we have a guitar, then of course we want to output the action for that guitar. Instead of just using action here, we will want to make a post request. Guitars, we want to include the guitar ID because that's part of the URL. And actually, I think that's it. Let's take a look at what we generated before. Yes, that's all that we need. We need guitars / and then the guitars ID. That is what we are going to make that request to. And then we close out the if directive with a /if. But of course, we also want to output a form tag that has the action for creating a guitar. Well, if we have an if, it probably goes to say that we also have an else statement here. So we can essentially do the same thing, except that instead of using /guitars/ID, we don't have an ID in this particular case because we don't have a guitar. So we will send a post to just guitars. Now we need to address the make and the model. So if we have a guitar, we want to output that information. So we can do that very easily by just prepending make and model with guitar dot. And let's see how this is going to work. But of course, we first of all need to go to our controller and we need to render that view. So that was inside of create guitar. We also need to do the same thing inside of the edit guitar as well. So in this case, we will simply render, and then we want to render the guitars/form. Let's scroll on down to the edit function. And we once again want to do the same thing, except that we want to provide the guitar as the model for this. And so now we should be able to test this in the browser. So let's hop on over there and let's first try to edit a guitar. So we will edit the strat, and I forget that we have to authenticate now. Let's turn that off for the time being, just so that we don't have to have that other step. So we need to go to the auth controller, and inside of that check auth function, instead of checking the session, we are simply just going to set is authenticated to true. That's going to make things a lot easier. So let's go back, then go to Guitars 1 Edit, and we see our edit form. Now, just to prove that we aren't using the old view anymore, let's go to our view file. And in fact, I think we can probably delete this file entirely. So let's do that. We will need to update the controller for our guitars because it does import view, but we're not using it anymore, so that's okay. So with that completely gone, let's refresh the page and we will still see our form. So let's actually edit something. Let's change the model to Telecaster. We should see that change, and that's great. So now let's try to create a guitar. Now, notice we aren't getting any errors. Let's take a look at the console, and there's no errors there. So even though inside of our handlebars view, we used guitar.make and guitar.model, even when we didn't have a guitar, we don't get any error. Handlebars is just recognizing that this value isn't here, so it's not going to do anything with it. So let's create the Gibson Explorer. Let's save that, and we will see that entry in our guitar list. Now that we are using an actual view engine, let's make our application look a lot better because, well, it leaves a lot to be desired. And frankly, whenever we're done, it's still not going to look the best, but it will look a lot better than it does. So I'm going to replace the markup that is inside of our layout page, the main.handlebars file, and it's going to have some bootstrappy stuff. Now, overall, it's going to be the same. We still are outputting our body, but there's a nav bar using bootstrap classes. The body is inside of a container. Now, there's this class called content that we need to define in our own CSS to set some margin here. But overall, this is just a standard bootstrap nav bar. We have a link for home, we have a link for guitars. And in this section right here, I want to add links for logging in and logging out. Now, of course, we're going to show just one of those links based upon if the user is signed in or not. And that's primarily what we will focus on in this lesson. But there's a few things I want to do first to make things look visually better. Now, this change alone is going to go a long way because now we are importing Bootstrap via the CDN. And since our layout page is used on almost every one of our endpoints, that's going to be fine. We will need to do something for our home endpoint, but we'll get to that here in a moment because I want to go to our style.css and add a content class that sets a margin top of 65 pixels. So that if we go to the browser and refresh the page, it's going to look a lot better. However, that nav bar is very light. So let's go back to our nav bar. Let's change this to nav bar dark and BG dark. So that should make that a little more visible. And sure enough, it does. Now, if we go to home, we just see home page because we never changed our home route to render a view. So let's do this directly inside of views. Let's create a new file. We'll call it home.handlebars. And the content is just going to be a paragraph that we'll say welcome home. And then we will render this. So we need to open up our app.js file. And for this route right here, we want to call res render and then simply home. Now, because this is directly inside of the views folder, we don't need to specify anything else as far as the view name itself. So whenever we go back to the browser and refresh, there we go. We have a much nicer home page. So now let's focus on the login and log out links. And we already know how to make decisions inside of handlebars. We use the if directive, and then we have some sort of condition. So in this particular case, we could use just user. So if we have user, then of course we want to display the log out link, because if we have a user, we are signed in, so therefore we need to log out. Now I'm going to make this look like a button, so I will use the button class and then button outline success, and then the text will simply be log out. But of course, there's two states here, so we need an else directive, followed by essentially the same thing, but it is going to take users to the login page, and the text is going to be login. And then we will close out that if directive. Now, if we go to the browser and take a look at this right now, we are going to see login, and that's perfect. We would expect to see that because, well, we are not signed in. And in fact, let us go to the auth controller because I believe, yes, let's set this back so that we are actually checking to see if the user is authenticated. So let's refresh. Let's go to the login link, and we're going to make this look a lot better as well, but we'll get to that point. And let's sign in. So we sign in, we are now signed in, but we still see login over here. And to prove that we are still logged in, let's try to edit one of our guitars, and we will be able to see the edit form. Okay, so how do we make this work then? Well, we know that we can pass data to our views because we did that inside of our guitar's controller. Every time we render something, we usually pass some kind of data to that view so that we can display that data. So we could go to every one of our routes, and we could also include the user from our session. But that's a horrible idea because we have to go to every single route and pass that value to every single use of render. But thankfully, we have a better solution. We can write a little piece of middleware that will set a user variable that is available for all of our views. So let's go to our app.js file. And before we define any routes, we want to define this middleware. So we're going to call app_use. Then we will have just a very simple function where we need the request, response, and the next. And inside of here, let's go ahead and check to see if we are signed in. So if we have a user and if the user is authenticated. Yes, I know that that's redundant, but that's okay to have some redundancy. So essentially, if we have a signed in user, then we are going to use our response object. We have a property called locals. And despite its name, this is essentially a global variable or a global object that is available to our views. And then we just specify what value that we want to provide. We'll call this user, and we will set that equal to the user from our session. And then finally, we want to call next, because if we don't call next, then processing on every request is going to stop with this middleware, and our application isn't going to work. So with that very simple change in place, we can go back to the browser. Let's refresh. And we need to sign in. So let's do that. And keep a look on the top right-hand corner. Login should change to log out. And it doesn't matter where we go now throughout our application, that user variable is available throughout all of our views. So every link we visit, every page is going to reference that user variable and show the correct log in or log out link. So let's log out. We will see that it changes to log in, and it will stay log in until we sign in. I want to spend a few moments with our login page because, well, it's horrible. And we don't necessarily need the nav bar at the top. And we definitely don't need the link to the login form while we are on the login form. And in a lot of modern applications, whenever you sign in, you typically see an empty page. There, of course, might be some graphics or background colors or something, but typically we just see a form and nothing else. So I want to accomplish that for our application, and it's actually quite easy to do. We just need another layout. Let's first go to our login view, and I'm going to replace the markup here. Now it's nothing spectacular. It's almost the exact same form, except that now it has all of the bootstrappy stuff. So if we were to take a look at this in the browser, the fields are there, they're named the same. There's just the markup necessary to make it look like this, as opposed to what it looked like before. The next thing that we need to do is create a new layout. So inside of our layouts folder, let's create a new file. And for the lack of a better name, I'm going to just call it plain.handlebars. Now, it's going to be plain in that there's not going to be anything on the screen. It is still going to need bootstrap and all of that stuff. So let's start by taking the markup from our main layout. Let's paste that inside of the plain layout page. We can get rid of the nav bar. We can get rid of the content class on our div container element. And we can also get rid of the reference to our style sheet because we don't necessarily need that here. We could always add it back if we did. And then we need to go to our auth controller, because it's not enough to just have another layout. Whenever we call the render method, we need to specify that we want to use a different layout. And we do that in the object that we pass to our view. We add a property simply called layout, and then we give the name of the layout that we want to use, just simply plain in this case. So now whenever we go back to the browser, we can refresh and everything goes away. We just have our sign-in form. So we can sign in. And of course, after we sign in, we will be redirected and we are back to our main UI. And of course, we are going to continue to see this main UI until we sign out. And then we try to sign back in. So don't think that you have to be constrained to a single layout. You don't. And there are many cases when you would want to have different layouts for different purposes. We write software to work with data, and a lot of times we can store that data on the file system, but more often than not, we reach for a database to store our data. And when we write software, we essentially have to choose between two types of databases. We have relational databases, which use SQL or SQL as the query language, or we can choose a NoSQL database, which are also commonly referred to as document databases. Now, that doesn't mean that you store Word or PDF or those kinds of documents. Instead of a record, you store your data as an individual document. And for many of these NoSQL databases, they work and query with JSON. So when it comes to a Node application, a lot of developers reach for NoSQL databases like MongoDB. And we are going to do the same thing in this course. Now, one of the great things about MongoDB is that we don't have to install anything if we don't want to. Yes, they do have a version that we can install on our machine. But if we need to get up and running very quickly and we just need to develop something, then we can use what's called Atlas or MongoDB Atlas. This is their cloud database. And they have a free version so that you can use that to develop your applications. And that's what we are going to do because we don't have to install or configure anything. So if you want to follow along here, you will need to sign up for a free MongoDB Atlas account. I have to admit, it's been a very long time since I created my account, but if it's anything like it was when I signed up, it is a straightforward process. And after you sign in, you will want to create a database. Now, in order to do that, you need to create a project. So let's create a new project, and we can call this whatever we want. I'm going to call it Node Fundamentals. Click Next, and then you are given the opportunity to add members. So these are users to this project, which, well, we don't need any. It's going to automatically add us as the project owner. So let's just go ahead and create that project. And then it will prompt you to create a database. Now, you have several options to choose from. One of them is free. If you want to pay for it, feel free to do so. But the shared plan is a free database. Now it's limited. It's not going to have nearly the amount of processing power and space available as the other options, but for our purposes, this is going to be fine. Now there are several options for your database. Where do you want to host it? What region do you want to host it in? Just pick one that's fairly close to you. North Virginia is closer to me than Oregon, so that's what I'm going to use. And then let's just take the defaults and we will create this cluster. Next, it's going to ask us for a username and password for authentication. These are the credentials that we will use inside of our application to connect to our database so that we could actually work with it. I will use the username dbadmin and I will auto-generate a secure password. And thankfully, it gives you the ability to copy that so that you know what it is. I recommend going ahead and pasting that someplace so that we have a reference to it, because I have a bad habit of clearing my clipboard. And so now we have that password available. So we want to create that user, and then we need to talk about access. So because this database lives in the cloud, it's not going to allow you to connect to it by default. You essentially have to whitelist the networks that you want to have access to this database. So that could be your home network, that could be your work network. What matters is this IP address. So wherever you are, if you want access to your database at the place that you are right now, you will want to add your current IP address. And after you click Close and Finish, you now have a database ready to use. Now keep this open because we will need to come back here and get some connection info. But let's go to the command line, and we want to install a package called Mongoose. This is a library that makes it very easy to work with MongoDB. It's technically what's called an Object Relational Mapper, or ROM. After it is done installing, go ahead and run your application again because we need to test if we can connect to our database. So let's go to our application. We can close all of our files and we want to open up app.js. And we are going to import Mongoose from Mongoose, and then we will want to connect to our database. So we will do that by awaiting. We'll use Mongoose to call the connect method, and then we need to pass in our connection string. So this is where we need to go back to MongoDB. We need to click on the connect button and then choose the connect your application option. This is going to give us the URL that we need to pass to the connect method. So let's copy that and let's go back to our application and we will paste that URL into the connect method. Now we do need to replace password here. So thankfully, I copied that because I've already cleared out the clipboard. So we will paste that in, and then we will simply try to go to anywhere within our application. If we don't get an error, then everything will be fine. Let's take a look at the console, and everything is fine there. So we have successfully created a database and connected to it. Now, one thing we definitely don't want to do is store our username and our password here inside of our file. That's incredibly dangerous. If we happen to commit this to source control and that source control was publicly available, well, then everyone would have access to our username and our password. But we will look at how to deal with that in the next lesson. In the previous lesson, we created a MongoDB database in the cloud, and we connected our application to that database, but we used the username and the password directly inside of our source code, and that is a security concern. Now, one of the ways that we can get around this is by using environment variables. Every operating system has the ability to define variables. So we could create a system variable for our DB admin and then for our DB password. And then we could use those directly here inside of our application. But of course, that's going to vary based upon what operating system you are on. So instead, we will do something else. We will create a new file at the root of our project called .env. This is a file that will contain some key value pairs. Like for example, we will have a key of DB admin, and then we will set that equal to our username, which is simply dbadmin. But then we will have another key called db_password, which we will set to whatever our database password is. So let's grab that and let's paste that in. So the idea here is that these are environment variables for this particular application. They are not system variables, but as far as the application is concerned, it's going to be treated as a system variable. The only thing, however, is that Node doesn't read .env files by default, which is perfectly fine. We can install a package that will. So we will install a package called .env. And while this installs, let's go back to our app.js file, and we are going to import .env from .env. And then after we create our application and create our handlebars, we will call .env config. This is going to read our configuration so that now we will be able to get to those values through process.env and then whatever our key names are. So the first was dbadmin, and then the second was dbpassword. Now you might be thinking, how is this more secure than just having these values directly inside of our application? Well, we can configure our source control, which is typically Git these days, to ignore the .env file, so that as we commit changes to our repository, that file is not tracked. And so therefore, those values are stored safe, or at least as safe as the system is. So let's go back to our application. Let's run our application. It kind of helps to have a running application so that we can actually see it run, but let's refresh here. and we shouldn't see any errors. That looks good. If we take a look at the console, we don't get any errors there as well. So we are now ready to start using our MongoDB database. In the next lesson, we will create our guitar schema so that we can start storing our guitars in our database. Now that we finally have a database that we can work with, we need to create our guitar schema. Now, the schema is essentially the structure of the data that we are going to store. So we are going to store guitars. So the structure or the schema is going to be very close to the guitar objects that we have been using. In fact, it will be almost identical. So let's start by importing Mongoose, because Mongoose is going to give us the ability to define our schema. It's also going to give us the ability to create new documents or records and save them. And so to create a schema, we begin with a variable, which I'm just going to call guitar schema. And we want to new up the schema constructor. This is off of the Mongoose object. And then we just define the structure. So we are going to have a make, which is going to be a string. We will also have a model, which will be a string. Now, we don't have to worry too much about an ID, because as you will see, whenever we create our first guitar, an ID is automatically going to be applied to this document. But one thing to know is that NoSQL databases, or at least MongoDB, is case sensitive. Now, this is an issue because we do try to find guitars by a given make, and that make is a string. So if we try to find guitars by makes, then the values have to absolutely match. Otherwise, we won't get the information that we need. That is very different from a relational database where it's typically case insensitive. So we can get around this in a couple of different ways, but probably the most efficient is to just store another value here. We can call it make underscore lower. The idea being that this is going to be the lowercase string of the make. And so whenever we try to find a guitar by make, we will do our comparison with that particular value. So that is our schema. And now we need to create a model class, which typically begins with an uppercase letter, and it is typically the name of whatever type of object that we are working with. In this case, it is a guitar. So we create a model by calling the model method. We pass in the name of that model, which is essentially going to be the table if this was a relational database. And then we supply the schema for that model. So we create a schema, we create a model based upon that schema, and then after that, we can create our new guitar. So let's create a guitar so that, first of all, we can have one in the database, and then we will start to change our code to work with our MongoDB database. So we will new up the guitar constructor. We will specify the make, which will be Fender, the model will be Strat, and then we need to provide the make lower, which will be Fender, in all lowercase. We don't have to specify ID because the database is going to automatically take care of that. So now all we have to do is call guitar save, and we're done. So we can go back to the browser, and we need to go to one of the pages that's going to load that guitars model file, which we are here at guitars. So let's refresh, and it looks like everything worked okay. So we can go to our MongoDB, let's refresh, and we should have a new document. Yes, we have this database called test that has a collection called guitars, and here is our guitar. So we have make model and make underscore lower. Those are the values that we provided. The ID is this underscore ID, which is different than what we have. We just have ID, but we can make the adjustments that we need for that. And then there's this underscore underscore V. This is essentially the version of this particular document. So that's great. We now have data inside of our database. Let's change our application so that we start loading that information for our guitar list. So let's comment out the line where we create that guitar because, well, we have that guitar. We are good to go there. And we want to go to get all. So here we're just returning all of our guitars. Well, we don't need to do that anymore because we have our database. And instead, we will use our guitar model and we will call the find method. This is going to return all of our guitars. Now we do need to mark this function as async, but with that in place, let's go to the browser and let's see what happens. Now, it looks like nothing happened, and it kind of did. We did receive our data, but let's go to the command line, and we see that we have some warnings here. I'm not going to call them errors, but they're warnings. So here we can see that access has been denied to resolve the property ID because it is not an own property. Well, yeah, because we don't have ID. But we see the same thing for make, and we see the same thing for model. And it's because it's not an own property. So here's the thing about handlebars. If the data that we want to display is on the prototype, it is not going to show that information by default. We can go into the configuration and we can tell handlebars to look at the prototype. But by default, it is going to look for own properties. So those are properties that are directly on that particular object. Well, we can do that, but alternatively, we could take the data that's coming from the database and essentially recreate objects that our application can use. That sounds like a lot of work, but that's also a very good practice to get into, because very, very, very rarely do we want to take data straight from the database and send it to the view. Now, for our guitars, there's nothing important there. But if we are working with user data or anything that contains sensitive information, we want to filter out anything that we do not want leaked to the client. So it's a good practice to get into. So here inside of our list guitars controller function, we're going to change this so that we will still have our guitars, but we are going to take the results from our database query and we are going to map that into a completely new object to where we have an ID, which is given to us from the _ID property. We will have the make, which will be g.make, and then finally model from g.model. We don't need the make _lower in this particular case because the client doesn't need that information. We don't need that information, so we should be good to go. So let's take a look at that in the browser. Let's see if that's going to work, and it should. That's taken a while. There we go, and voila, we have our Fender Strat. Now, I will say that this is a process that we are going to need to do multiple times, so it kind of makes sense to go ahead and break this functionality out into a function that we can use. So we can just call this convert to obj. I'm sure that there's a much better name that we could give this function, but this is going to be fine, to where we accept the guitar object that's coming from our database and we return a new object that has just the properties that we need. Now, one thing you might have noticed is that the ID is not a numeric value anymore. It is a string that is 24 characters long. So that means we will need to make quite a few adjustments here inside of our guitar controller. But it'll be easy enough to do. It will also simplify some of these functions as well. Now we need to fix this syntax error here. Since we broke that functionality out into a function, we can use the convert to obj here. Let's just do a sanity check, make sure that that is going to work, and it does. So on the next lesson, we can focus on the code for displaying the individual guitars as well as the search by make. In the previous lesson, we created our database schema and model, and we created a document. We are displaying that document in the list, but that's it. We have some more work that we need to do. So let's start inside of our controller, where we show a guitar. Now, of course, this function does double duty. It shows an individual guitar or it shows guitars by make. But one thing that we need to address is the ID, because it is no longer a numeric value. If we take a look at the ID, we can see that it is a string of 24 characters. So the naive approach would be to just see if the ID is 24 characters and go from there. And that's what we are going to do, because why not? So I'm going to write another helper function because this is also something that we will need to do very frequently. So let's have a function called isID valid, to where we will accept the ID and we will simply check if the length of ID is equal to 24. That way, if we ever need to change the criteria for the ID, we can just come to this function and make those necessary changes, and we're done there. So we need to get rid of the call to parse int because it is not an int, it is a string. And then for this first if statement, we will check if it is a valid ID. And if so, we pass the ID to getById, which we need to adjust here. If we don't have guitar, we return 404. Otherwise, we send that guitar to the view. So here we want to take the guitar coming from the database and we want to convert it to obj so that we can properly view that in the view. Now we need to adjust getById. So let's hop on over there and let's make the necessary changes. So getById is now a string and we need to use our MongoDB. So we are going to return guitar dot, and we have a method called findById. How nice. And we can pass in the ID, and there we go. That's all that we need to do as far as that method is concerned. And so now we need to take a look at the other part of this function to where we try to find the guitar by make. Now we will address get by make from our model here in a moment, but whenever we send the guitars to the view, we need to do what we did in the previous lesson. We need to map what we found from the database, and we need to convert all of those to our obj. So that view should work. We just need to change our get by make. So let's go to that function. And this is going to be a little bit different, but it's going to be much more simple because we have a method on our guitar model simply called find. Then we pass in an object that has the property that we want to compare with. So make underscore lower, and we want those that are equal to the provided make set to lowercase. Now we need to make this async, and we should have made get by ID asynchronous as well. So let's go ahead and make that change. But with those simple changes, we should now be able to go to the individual page for this guitar. So let's try to go to Fender Strat. That works. That's perfect. Wow, that worked the first time. Let's do a search for Fender. So we go to guitars made by Fender. Once again, we get our list. So 2 for 2 off of that. That's really something. It's time to go buy a lottery ticket. Now, inside of our controller, we have a few other places where we can use those model functions. Like, for example, the update guitar method is, nope, that's not one. What am I looking for? Wherever we display the edit form, there it is, edit guitar. So once again, we get the ID. We don't need to parse that as an int, but we do need to check if it is a valid ID. And in this case, if it is not, then it returns a 404. Otherwise, we get the ID and we need to convert that to obj. So let's take a look at the edit view, although there might have been an error there. There is. And we need to give this a property name. So now let's go to the edit form. So let's go to the individual guitar. Let's go to /edit, and we need to sign in. The edit page looks horrible, but it is working. So at least displaying the form is going to work. And so now we need to implement the code for actually saving that edit, which was the update guitar. Once again, we need to clear out the code that parsed our parameter as an int. We need to check if ID is valid. And if it is, then we get the guitar. Now, I'm going to say that I want to change this because now I don't want to modify these values outside of our model function. I believe that the model function should be the one that is making these changes. So what I'm going to do is just get rid of where we attempt to retrieve that guitar. Because ultimately, if someone is going to make a post request for update guitar, and that guitar doesn't exist, we don't need to tell the user a 404. We can just redirect them and that would be fine. So this means we need to change what we are going to pass to our save guitar function. And we can pass in the ID because we need that. We also need the guitar make and we need the guitar model. We will leave everything else here, but now we need to go to save guitar and make those changes. So that should be easy enough to do. We have ID, we have make, and we have model. And here is where we will attempt to get that guitar. And thankfully, we already have a function to make that easy to do, get by ID. And let's check to see if we have a guitar. And if so, then we will make our changes so that the guitar make will be equal to make, the guitar model will be equal to model, but then we also need to set the make underscore lower, and we need to set that to make to lowercase. And then after we make those changes, we just call the save function, and that will save our guitar. Let's mark this as asynchronous, and then let's test this. So let's go to the browser. After we sign in again and we change a value, we attempt to save it, and we can see that that saved. Now let's go to our database and let's see if that actually changed. So let's refresh our data. And there it is. We can see that our model is now Telecaster. In the next lesson, we will continue this process of migrating our code to using MongoDB so that we can create guitars and delete them. In the previous lesson, we started to update our model file so that we can interact with our database in order to display our guitars and edit them. Now we just need to finish this process and implement the code for removing guitars and making guitars. So let's start with removing, because that's really the more straightforward of the two options. And let's start with the controller, because let's see what data we are working with. So let's scroll on up to the delete guitar function. Once again, get rid of parseInt. We will use our isIdValid function. And if it's not, then we return 0404. But then this was another case where we attempt to get the guitar so that if it doesn't exist, we once again return 0404. I don't think we need to do that, because ultimately the database isn't going to care. If we provide an ID that doesn't exist, it won't throw an error or anything like that. So all we need to supply to the remove guitar function is the ID. So let's go to our model file and let's modify our remove guitar function so that we receive the ID and we simply want to delete the record with that particular ID. So to do that, we use our guitar model. Once again, we have a method called delete1, and then we specify what criteria we want to do to find the document to delete. So in this case, the underscore ID needs to equal the ID that was supplied to our remove guitar function, and that should work. So let's test this out. Let's go to the browser and let's go to /delete, although we are going to have to sign in again. But after we sign in, we can go back to the guitar, we can go to /delete, and that guitar is now gone. We don't see it in our list. And if we go to our database and refresh, we will see that we no longer have a guitar document inside of our guitars collection. So that code works perfectly. We just need now to create a guitar. Once again, let's go back to our controller and let's take a look at the store guitar function. So we receive the guitar make and the guitar model. We pass that on to the add guitar function, and that's great. That's all that we need to do. So let's look at the add guitar function. We no longer need to work with our guitars array. Instead, we will await. We will call guitar.create. We could new up the new guitar like we did a few lessons ago, but this is just another way that we can do this, because if we call create, then we don't have to call save. It's going to automatically save for us. So we will set all of our properties, and we need to mark this function as asynchronous, but that should be it. So now we can get rid of all of our old code and anything else that is not being used here. Let's save this and let's go to our application and create a new guitar. Let's create the Fender Strat first. That was successful. Let's now create the PRS Starla. That was successful. Let's once again create another guitar. This will be the Gibson Les Paul. And I think that we don't need to keep testing this because, as we can see, we can create guitars, we can delete guitars, we can edit them, and of course, we can list them. So let's take a look at the database just to see what our new structure is going to look like. We will have multiple documents now, each one, of course, with their own unique ID. We can see the make, the model, and then the lowercase make for our searches, and that is a wonderful, wonderful thing. Well, in the next lesson, we need to continue working with our database because we need to store our user information, because the way that we have done that is, is very, very bad. I want to spend a few minutes talking about security because especially in today's day and age, security is paramount. And since we are writing web applications, the implication is that we are going to publish these things on the internet. So it is publicly available and it will be probed and it will be attacked. It might not happen within the first month or the first year or the first 10 years, but eventually it will happen. Now, we could spend a lot of time talking about security, but what I want to focus on is on line 11 inside of our auth controller. This is inside of the authenticate function where we are taking the login form and we are checking to see if the email address the user supplied is equal to what we hard-coded and the password is equal to what we hard-coded. So this brings me to the first rule. Never, ever include sensitive information in your application's source code. Find some other way to store it and get that information into your application. Like for example, whenever we connect to our MongoDB, we have this connection string, but the DB admin and the DB password are inside of a .env file, which is not part of our application code. Now, the .env file is a completely different thing, which we will talk about here later on, but for right now, I want to focus on just the user credentials that are used to sign into our application. So we don't want this information directly inside of our application. Instead, we want to store our user credentials inside of the database, but we also want to obscure the passwords so that if the database ever got compromised and someone was looking at the records, they wouldn't see the actual passwords. So the way that we can obscure a text value is to either encrypt it or to hash it. Now, encryption also means that it can be decrypted, which in a lot of circles is less secure, especially when it comes to user credentials. But there are many systems that allow you to decrypt the password. So I will leave that decision up to you if you want to go that route. Hashing is a process of taking a plain text value and then scrambling it up. It's a lot more than scrambling it up. It completely obscures it so that if you looked at it, you would have no idea what that value is. And there's no way to decrypt it because it is a hash. And so what we are going to do is create a setup script so that we can provide the username and password. We're going to store that information in the database and we are going to hash the password. Then we are going to update this code so that we take the user input, we try to find a match in the database, and then that will determine whether or not the user is authenticated. So in order to hash a value, we need to install a library. And the standard library that's used not just in Node, but across multiple platforms is called bcrypt. So we are going to install this, and then we will fire up our application. And we're going to create a module that will have a couple of helper functions to make it just a little bit easier to hash and then compare values. Now, hashing with bcrypt is simple to begin with, but this is just going to make it even easier. So inside of our auth folder, I'm going to create a new file. We'll just call it crypt.js. And the first thing we need to do is import 3 functions from bcrypt. The first one is called gen_salt for generating the salt. Whenever you are hashing a value, you want to supply a salt because the salt is going to make our hash more secure. The second function we want to import is called hash, but I'm going to use an alias called gen_hash. The idea being that this is going to generate the hash for a value. And the reason why I'm using an alias here is because I want to export a function called hash. That leads us to the third function called compare, which is used to compare a plain text value with its hash. But once again, I'm going to use an alias called compare value. Once again, because I want to export a function called compare, and these are all from bcrypt. Now let's go ahead and let's start defining the hash function. So we are going to export this, and we can use an arrow function because this is going to be pretty simple. This does need to be async, and we are going to accept the input. So this is going to be plain text. And in fact, let me change this to plain text. It helps to know what kind of data that you're working with if your variable names represent that kind of data, especially when it comes to hashing or encrypting and decrypting. So the first thing that we need to do here is generate our salt, because anytime you hash a value, you want some salt. Now, the way that salting works in bcrypt is we provide a number. Now, this number indicates the what we would call the salt rounds. The higher the number, the more secure the hash is going to be from attacks, but it's also going to take a longer amount of time. So the balance here is to find a number that is both quick but also secure. The default is 10. So if we do 12, it's going to take longer, but it is going to be more secure than using 10 rounds. And then we want to await and call gen hash. This is going to generate the hash so that we pass in the plain text and then we pass in the salt, and then we will get our hash value. Now, a hash cannot be decrypted, but it can be compared to its plain text. So we will have this function called compare. This is going to be async as well, and we are going to provide two things, the plain text and then the hash that we want to compare it to. And this is where we will use the compare value function, which is actually the compare function coming from bcrypt. But once again, I'm using that alias, and then we provide the plain text and the hash. Now, this is going to return a Boolean value. If the hash is of the plain text, then it will return true. Otherwise, it's going to return false. Now, let me stop here. There are some other strategies that you can use in conjunction with just generating the salt. If you wanted to make this a little more secure, you could include some kind of arbitrary text before or after, or something that is just not expected. But once again, this is information that you would want to store outside of the application, like inside of the .env file. But the only caveat is that you would also need to provide that same text whenever you compare the value, but it does make it a little more secure. I'm just throwing that out there. Okay, so this is going to generate a hash for us. This is also going to allow us to compare some plain text with a particular hash. Now we just need to use this, and we will in the next lesson by creating a setup script. But before we get to that, let's talk about this .env file. So I've said that we don't want to include user credentials or any kind of sensitive information directly inside of our application's code. Now, the .env file is not part of our application's code. It is sitting here with our application, but it is not part of the code. So if our application encountered an error, and let's say the connection string was leaked out because of that error, let's say that it was displayed in the browser, then at least our application would be protected because the admin and the password are not part of the code. So we're protected there. But just the .env file itself, you can ask any set of developers if you should encrypt this file, and you are going to get a mixed set of answers. There will be some that say yes, and I imagine there will be a lot more that say no. And there are some very good reasons why you don't want to encrypt this file. For one, encrypting the file just complicates your application so much more, almost to the point that it's not worth it. The second reason is that the .env file should not be tracked or committed with source control. So if you use git, and if your git ignore file is set up correctly, then the .env file is never going to make it to the repository. So it's secure in that sense. But third, the machine that the application runs on should be secure to the point that no one should be able to access or gain access to that machine except for the people that should have access to it. And even then, the .env file itself should similarly be protected so that only the people that need access to that file have access. Otherwise, no one else does. So as long as the system is secure, the .env file is secure. So we don't have to worry about hashing these values or encrypting them because the system itself that the application runs on should be secure as well. In this lesson, we are going to create a setup script so that whoever is deploying this application can run the script, provide the email address and the password. Then we will modify our auth controller to retrieve the user from the database and then attempt to authenticate the password. So the first thing that we need is our user model. So inside of the auth folder, let's create a model file. And let's just open up the model from the guitars and let's use these first few lines as a basis. That way we don't have to write everything from scratch. Now, of course, the schema is going to be the user schema, and we need the email address and the password. Both of those are going to be string. Now, of course, we could have other information about the user if we wanted, but for our purposes, this is going to be fine. Now, we want to export this model that we are going to call user, and the name is going to be user, and of course we need to specify the user schema there. So that gets us our model that we can use. So we're good there. Now we just need to create our setup script, and I'm going to do this at the root of the application. Now, we could make this an actual page within the application itself, but I don't particularly like that approach. I like that this would be an offline setup. So that's what we are going to do. And there's quite a few things that we need to import. In fact, let's open up our app.js file because we can copy some of these, like mongoose.env. We need to call the .env-config method. We also need to connect to our database. So with those lines of code, that will give us a good start. We don't need to create an Express app or handlebars. Okay, so from here, we are going to be working with the command line. This is, of course, a command line application, so we need to import ReadLine so that we can interact with the user's input from the console. And if we are going to use ReadLine, we need the standard input and standard output. I'm going to alias these as input and output. Now we need to import our hash function from our crypt module, and we also need to import our user model as well. But I think that gets all of our imports. Now we just need to create our ReadLine object. So let's do that before we connect to the database. So let's call .env-config. Then we will create our ReadLine interface, and then we can begin asking our questions. So let's do this. We will ask our question. In this case, we want to prompt the user to provide their email address. And then let's just use our callback functions. We don't need to do anything fancy here. So we will get the email address, and then we want to ask them to provide a password. And once again, we will use the callback function. Now this will be asynchronous because our hashing is asynchronous as well as the saving to the database. And let's call this plain text, not password, just to be clear as to what kind of data that we are working with here. And the first thing that we want to do is hash that password. So we will have hash text. We will call our hash function. We will pass in our plain text password, and that will give us our hash so that then we can await user create, and we just need to supply the email address. And let's do this. Let's call to lowercase on the email, because email addresses are not case sensitive, but when it comes to trying to find the user by email, we want a normalized string, because remember that strings are case sensitive in MongoDB. So we have our email address, then we will set the password to our hash text, and that should be good, so that after we do that, we will close the ReadLine interface. Now our hash, we need to await that as well. Okay, so let's give this a shot. Let's go to the command line and we will just run our setup.js. We should be prompted to provide the email address. So that was admin@admin.com. And then a password, we'll just have password. And well, that's just kind of sitting there. I expected it to end. But I'll tell you what, let's go to the browser and let's take a look at our database. So let's refresh this, and hopefully we will have a users collection, which we do, and hopefully we will have a document, and we do as well. So we see the email, and we have our password, and that's a heck of a password, but that's what a hash is. That is why we hash our passwords. All right, so with that in place, let's close this script. I'm not going to worry about it not exiting because we can just as easily exit it. And we're going to run our application. So now we need to go to our auth controller because we need to make our authenticate function, first of all, try to find the user with that email address. But we need to import the user model. So let's just copy that import line and let's paste this in. Of course, we need to change the path here to just simply /model. And so after we check if we have an email address and a password, we want to attempt to get the user. So we will await, we'll use our user model, and we will call the find1 method. We want to find the user with an email equal to the email that was provided, and we need to set that to lowercase. Now we do need to mark this function as asynchronous, so let's do that. So let's do this. If we don't find a user, then we will simply just redirect back to the login screen. Ideally, we would tell them that it doesn't exist. But, one of the things about security is, we want to be as helpful to the user as possible, but unfortunately, we have to consider that any attempt to authenticate is not legitimate. So any message that we would supply to the user should just say invalid login or something like that. We need to be as vague as possible, not this user was found, but the password was wrong. We don't want to do that. All right, so if we don't have a user, we simply redirect. Otherwise, we want to compare the password with the hash from the database. So this is where we need to import the compare function. That's not from bcrypt. This is from our own crypt module. We need to await this, and then we pass in the plain text password followed by the hash from our user object. And if that is successful, then we sign the user in. If not, we redirect back to login. All right, so let's give this a shot. Let's go to the browser, and I tell you what, here we are at login, and let's first try to sign in with invalid credentials. The password doesn't matter. We click on sign in. We should just get redirected. Perfect. That's great. So now let's try to sign in with valid credentials, and hopefully we will be redirected to /guitars, and we are. So we are now authenticated. If we try to do anything that an authenticated user has access to, well, sure enough, we can make those changes. We can save it, and voila, everything works. And most importantly, our user credentials are no longer within our application code. They are safely stored within our database, and the password is hashed, so that even if this data leaked, they would have to find comparable hashes, and depending upon how we hashed our password, that could take a really, really long time. I've developed web applications since 1998 using a variety of languages and platforms, but Node.js is something special. It revolutionized the way that we build web applications, but more importantly, it thrusts JavaScript into the spotlight. Because of Node, JavaScript was suddenly taken seriously in the world of programming. Before then, JavaScript was no less important, but quote-unquote real developers discarded JavaScript as a funky little broken language that was only good for making things move around on a web page. Now, it is the most popular and most important programming language. Now, I know it's very easy to get overwhelmed, especially with Node and Express, but it is my hope that by now you are confident in your knowledge with these technologies and that you can start building your own projects. Node is actively developed and continues to implement new features and capabilities. And of course, NPM is the backbone of handling dependencies for not just Node applications, but web development in general. Thank you so much for watching this course. Please feel free to get in touch if you have any questions. And if you found this course useful, please like and subscribe to the channel. I am Jeremy McPeak with Envato Tuts Plus, and from all of us, thank you. I will see you next time.